Welcome to Distributed Django with IoT. The idea here is how can we have Django run on a bunch of different small devices like a Raspberry Pi. That's the key. That's what we're going to be doing. Let's talk about it. Now, of course, we're going to be using Python and Django. Django is, of course, a web framework. So how is it that we want to distribute this? Realistically, we're going to be using Django on how it integrates with Celery. That process is actually very straightforward, but doing so in a distributed manner is super effective and super useful. So what we're going to be using a lot of this is the Django models, the Django ORM, so that we can start monitoring and getting time series data. That is, these Raspberry Pis are really good at integrating with sensors. So those sensors that you might want to use would be done over time. Like, hey, what temperature is it now? What is it now? What is it now? Right? So over time, we want to collect that data. And so when we do that, we want to have a database that's ready and stored and ready for all of that sort of time series data. For that reason, we are using TimescaleDB. Yes, they are a sponsor of this course, but the idea here is using Postgres, the thing that you know and love, with Django and having the ability to do time series data with very, very little overhead on what you actually need to do, what you actually need to code up to make this work in a very powerful manner. So once we actually learn how to do the distributed Django of it all, that includes using Docker Compose and Raspberry Pis, then we start building out an API service. The API service, of course, is going to be using Django Ninja. Once we have that API service in place, we can start visualizing the data, something like this. Now, the reason this data doesn't really have that much of a rhyme or reason is because we actually do a bunch of random data, but the idea is still here. We actually will visualize the data, we'll do all the queries, all of the things necessary to really understand how to use time series data in our project. Now, of course, there's a lot of built-in tools that we will be able to use with this, but the overall goal is to see how you can use distributed Django and how you can use time series data. These things work in tandem really well. It makes a lot of sense when you start to distribute your Django project that you're going to use it for time series data. What we're not going to be using it for is fulfilling user requests, as in what Django is usually really good for, handling users coming in and coming out. It's really all about the Django ORM, how we can handle different queries, how we can actually store data into the database, and of course, how it integrates with Celery. So if this is exciting to you at all, please jump into the course. I'm really excited about it. Let's go ahead and take a look at the demo, or at least some of the code from the demo right now. Now, what you see right here is, of course, data being rendered in the front end. And as a demo, it's not really that exciting because it doesn't really show us that much about what's going on under the hood. Collecting the data, getting the data as time series data is what's the important part here. We're building out a distributed pipeline so we can actually start having data coming in from different sources, but all managed through one single code base. That, of course, is our Django and Celery project. Now, the other thing that's really cool about this is I do show you how to deploy it on Raspberry Pis in your local network. And so if you see here, I've got django-pi.local. This is quite literally the Django project that's running, that's storing all of that same data. The reason that my Raspberry Pis can see the same data as something like my local Django project running has to do with the mere fact that we are using a production-grade database in Timescale. Timescale is being run on all of these different devices, or at least integrated with all of these different devices. And you could do this with a lot of things. So it's really, really powerful to make this happen and super reliable. Timescale, of course, is probably more reliable than our current setup, but the idea here is rendering out this data does take some time to get to this point. So let's actually take a look at the code at a high level as to what's going on. Now, first and foremost, of course, it's the Django project. So we build out Django. We do some models in here. Here is the baseline model. You actually don't have to spend that much more time in here other than doing this timescale model. This is essentially a Django model with optimizations for timescale directly. That gives us another field in here called time, which is also really nice. Now, to use this, we also go ahead and create various services on here, which I'll show you on my local project here. We've got our various services inside of our sensors, which is this. These are different aggregations and queries that you can do into your timescale database based off of your actual time, the time ranges that are coming through and all of that. And Timescale does this by default, and it makes it really, really easy to make this happen for time series data as we go in and collect. Now, what the Celery portion is going to do is it's just going to do a simple task, one simple task that's going to be run on different nodes. So each instance that's running Celery will have a different ID. That different ID will be factored into creating these different metrics, thus distributing Django into more places. Now, when you actually run Celery in different places using Docker Compose, it's actually very straightforward. So what we see here is we've got, first off, our Django base. We do show you how to do self-managed TimescaleDB as well. You've got a Redis database in here also self-managed. And then we create our base Django project here. I show you how to do all of this. Even if you haven't used Docker before, this part is actually fairly straightforward from my view. Once you actually get all of that going, then we use that same iteration over and over again and just modify it a little bit to being based off of the actual node ID and a different queue for each Django Celery process. And then of course we have one beat server to make sure that all of these nodes are running on a regular basis. Now, I could spend hours talking about all of this stuff. The general idea is that we have this project here that we can then distribute in a way that maybe you have never done before. At least I haven't seen it done online before in distributed Django in this tutorial series. So the other idea here is, of course, we also use Ansible. Now, so much of this is I just give to you mostly because we could do a whole course on Ansible itself, but the idea is we use Ansible in the different playbooks to configure each one of these devices automatically. You can use a lot of this information to do it manually, but doing it automatically makes a lot of sense when you start doing basically more than one. Even if you're doing one, you should probably do it automatically. So we go through that as well. And as you can see, we have a bunch of different setup for different environment variables. And of course, here are the different requirements, the different things that we're going to be going over. Django Ninja is one of my favorite ways to build out REST APIs. We see that there's Django, Celery, Redis, no surprises there. Then we've got our Postgres integration and of course the Django+Timescaledb package. So we've got a lot of stuff in here. Let's talk about the actual requirements, the technical requirements you'll probably need to do well in this course. Now, granted, if you have any questions on the demo, please let me know in the comments. Otherwise, let's jump in. Let's talk about the technical requirements you will need to do well in this course. First and foremost, knowing some things about Python is absolutely critical. So if you know how to write functions, classes, variables, some math, you'll probably do okay in this course, assuming that you also have a little bit of experience with Django. So in the case of Django, you need to know how to be able to do models, maybe some views, some schema migrations, or database migrations. The idea is fairly straightforward with Django itself. We're not going to be doing a lot of the more complex things that you can do with Django because this is about distributing Django across different devices using Celery. So we'll also integrate Django with Celery as well. If you've never done this, I think it's a really fascinating project itself. Now, another part about this, if you need to learn Django or even Celery, check out my YouTube channel at cfe.sh/YouTube. In here, you'll see different playlists for learning Django itself, but I also have some for using Celery as well for other projects in altogether. Now, what we'll be also using is a tool called Docker. This allows us to distribute Django on multiple instances on our own computer, on our local computer. As you saw in the demo, we actually went through this a little bit, but the idea is knowing a little bit about Docker and having Docker installed will be a very beneficial thing for you. Now, of course, we are going to be using Timescale as our Postgres database. So the question might be, do you need to know how to use Timescale or Postgres? Both answer is no, you don't need to know how to do either one of those things. Django itself handles the heavy lifting for the Postgres part of things, and then the Django timescale package that we end up using, it handles the timescale part of it for us. That's the point. It's meant to be very simple and straightforward in terms of the technology itself. Now, I do write a little bit of JavaScript in Chart.js. This part is not really that robust or advanced whatsoever. It's really just to show a proof of concept so you can have something like this. So knowing a little bit about JavaScript is helpful, but I'm going to show you how to do it. So if you know a lot about Python, seeing it in JavaScript, well, it might make you a little bit more interested in JavaScript altogether. Because it's really just a lot of copy and paste in the Chart.js world, so you can get something like this. So as far as technical requirements, that's really it. If some of these things feel uncomfortable, or if the demo felt like I was going way too fast in terms of the technology and overview of things, I definitely slow things down a little bit, but this is definitely for those of you who have some familiarity with Django. But if this is an exciting topic for you in terms of doing distributed computing and also distributed Django and also time series, well, this is the course for you. And I do recommend that you give it a shot, even if it's a little bit challenging at times, because all of the code is available for you on the GitHub. So you can always go back and forth referencing the actual code we use throughout this series. So without further ado, let's jump right into it. Let's go ahead and configure our root Django project here. So what we want to do, of course, is open up VS Code. We're going to open up a brand new folder. I put this folder in my root user folder and then in a dev folder for that. And then I go ahead and create a new one. In this case, I'm going to call it Django IoT, or Internet of Things. I think Django Edge is another idea that actually makes sense here. But the idea is, how do we actually run Django multiple times in multiple places under really one project? That's a big part of what we're doing here. So however you end up naming it, it doesn't have to be IoT, but I think it actually helps us understand that this is meant to be run on many different devices, and that's thus the name. But the idea here, though, so far, it's going to take us a while before we actually have the IoT of it all, where we actually use sensors with our Django project. So in the first part here, we're really just going to be setting up Django to make sure it's working locally before we actually go to the edge and actually distribute it in multiple places. So with this in mind, we have our now root project almost set up. I want to start with requirements.txt. So whenever you actually start a Django project or a Python project, a lot of times you want to declare what your requirements are going to be. Of course, Django is one of them. And if we were to go to djangoproject.com into the download portion, we will see that the current iteration is 5.06. I actually recommend getting the LTS. We're going to stick with 5, but the LTS of 5.2 is not really that far away, but it is going to be well supported. So realistically, you can even use Django 4.2. What we're going to be doing here is not really pushing the bounds of what Django can do for any given version. So much of what we're doing here can work on any version of Django, but we want to make sure that we can actually just declare that we are using Django between 5 and 5.1, just to make sure we have those requirements in. Next up, we're going to be using Celery and Redis. We'll talk about that more later, but of course, those are some key packages that we will be using to make sure that Django is actually distributed and working in a distributed manner, mostly because of Celery and Redis. Next up, we're going to go ahead and bring in our Django.DB database URL package. This will make it really easy to use our TimescaleDB in a little bit, and this will also mean our scopg binary. This, of course, is version 3. The old one was scop 2, which is not what we want. We want version 3. A lot of documentation out there. You'll probably see version 2 on there. Using the binary just makes it a lot easier to connect and not need a bunch of other dependencies in there. Next up, we're going to go ahead and bring in Python Decouple. This will load in our environment variables, but I'm going to do it in a way that actually extends Python Decouple, as we'll see very, very soon. We'll also bring in Django-TimescaleDB. This is a package that makes it really easy for Django to work with TimescaleDB and time series data. Then we're going to have a few other aspects in here that we'll use to make sure that we're running this correctly and all of that. Kombu is for Celery, Gunicorn is for running our Django project in production, and we may or may not use white noise, but I'll go ahead and bring it in for loading static files in our Django project. So now that we've got all of those requirements out of the way, I'm going to go ahead and create a virtual environment. Now I'm going to be using Python 3.12. Now you should use at least 3.10. So in python.org, we probably already talked about this, but the idea being that whatever the version is, go ahead and download it and get it working. If you're on Windows, I recommend using WSL or Windows Subsystem for Linux instead of like PowerShell. But either way, use the version that works for you. And then I'm going to go ahead and create a virtual environment right inside of the root of this project. Of course, this is how it's done. Now, I know this is basic stuff for a lot of you, and feel free to skip it. But the idea being, we want to make sure that we set this up correctly before we go much further. So having this virtual environment, make sure that we isolate these requirements from anything else on our project or our system. We're going to see better isolation later, but for now, this is actually pretty good. So we'll go ahead and do source venv bin/activate. Of course, if you're on Windows and you are using PowerShell, you'll do something more like scripts activate, something like that. But do check the Windows documentation for that. And so now that we have a activated virtual environment, we'll go ahead and do pip install dash upgrade pip. And of course, this will upgrade the virtual environment version of the Python package installer. And then we'll do pip install -r requirements.txt. And once we have that, we are going to go ahead and then make our src folder here. src will be all of our Django's source code. And then I want to navigate into there in my terminal. This is where I'll just run django-admin start project CFE home and period. I call all of my Django projects CFE home, so I know exactly where the settings module is, or the root settings module for Django is always in the CFE home setting, as you'll see on so many of my projects, and that's exactly where it is. And so there we go. Now we have our Django project started, and I'll go ahead and run the server just to verify, hey, hello world, we have our Django up and going. Great. So now what we want to do is start the process of loading in environment variables right out of the gates, because they are so important to how we use all of this project, as we'll see going forward. Now, when it comes to a lot of standard projects, what you can do is you can use just .env to handle your environment variables locally. So inside of my src folder here, if I were to go into settings, for example, and I just wanted to pull out the Django secret key and put it into here as something like Django and secret key, and then set that in just like that, I could then use Python decouple in here. So we can go ahead and say from decouple, and we can import config, and then we can just say config and, Django secret key, and then we'll cast it as a string or something along those lines. So this, of course, is absolutely what you want to do at the baseline. But the thing is, we are going to be using Docker really soon, Docker and Docker Compose, to allow us to have a bunch of different locally testing environments. So that is Redis and TimescaleDB in the short run, but in the long run, we want to be able to test out a bunch of things related to our project. So having our environment variables decoupled is really important, and that's why I actually use Python decouple for that. There are other ways to do it, but what I want to do now is I want to use Python decouple and augment it a little bit so that I can have multiple environment variable files on my project. So the way I'm going to do this is inside of src, I'm going to create a helpers folder, and I'm going to do that by just doing a new file in VS Code and then using a slash there. This actually creates a folder and the module for you, assuming that you put in a slash, which is super nice. Inside of helpers, I'm going to go ahead and create env.py, and inside of here, we're going to go ahead and do a bunch of things related to our environment variables. So one of the first things that I can grab is the pathlib baster. So I can actually copy this from settings.py and paste in here. What this will do is this will give us our base directory, as in where manage.py is. You might already know that, but that's the idea from the get-go. Next up is going to be our repo dir, and this is going to be the baster and parent. So the repo directory is the default location that Python decouple will look for. So in this case, if I break down src, I've got .env in here. Now you might want to have this in other places, right? So maybe you have a baster env, and this would be baster/.env. That's possible. You also might have a repo dir env, which of course, like I said, is the default, but you might as well put it in here as well. And then another one you might want to have is our repo dir, let's say something like web env, and this of course will be our base directory /.env.web. And in which case we can actually have multiple now, and I can just come in here and do env.web. Now I have multiple environment variables that I can use, or well, close to using in our actual project. But going back into the helpers here now, I need to actually adjust how Python decouple works to actually register based off of these various things. And that's actually what I want to go about do. So the way we're going to do this is we're going to create a method called getConfig. And what this will allow us to do is to return the same element of Python decouple's config, or basically the same thing. So by default, what we'll do is we'll just import that right in here and we'll return back config, just like that. So with this in mind, it's still using the standard setup, right? It didn't change anything yet. So what I can do for this as it currently stands is I can actually bring in config equaling to getConfig. Now, a big part of the reason my import here is not simply just imported above has to do with the fact that I'm using the same variable itself. Now, of course, there's other ways to do that, but there's another reason why I do this import, as you'll see in just a moment. But as it stands right now, I can go ahead and do from.env import that config now, and then we can export this into our all by just doing config. Now, back into my settings, what I can do is instead of decouple, I can just say from helpers. It's the exact same thing so far. Now I want to make it actually a little bit different. So the way I do this is I'm going to go ahead and come in here and say from decouple, we're going to import our config and the repository env class. So really what I want to do is I want to check the order as to which I want to import something. So for example, the baster env, like in SRC, perhaps that's the default one that I always want to have. So in other words, I can say if the baster env exists, then I can return back the configuration, the class itself for the repository env, and that's going to be based off of this location right here, which I will turn into a string. So basically, if this one exists, it's going to load those other ones in. And so now what I can do is I can duplicate this again with my web env. So if the web env exists, we put that one in. So we say elif, and then we can go ahead and grab one more, which would be like if the repo env exists, something like that. And there we go. So now we have the overall a better approach, I think, to being able to use different environment variables based off of priorities and whether or not they exist. Now, what would be really good would be to actually combine these, go with those priorities, being able to use all of them and have some fallback values. But all of that custom configuration just gets a little convoluted. So I'm just going to go with this, basically saying that if env.web exists, we're going to use that one. Unless there's an env inside of the SRC folder, we'll use that one. That's the idea. That's it. So to make this just a little bit more efficient, what we do is we import from the functools package. So from functools, we're going to import LRU cache, and then I'll go ahead and decorate our config here with LRU cache, which just means that our get config method is not going to be called continuously. It's only called once when we start up our project. But at this point, we now have a better method for handling all of our different environment variables. And going forward, I'm going to be using .env.web. Now, this might seem like a ridiculous thing to do this early in the project, but it's not because of how we end up using Docker Compose. This is still set up. This is still getting us ready for what we'll be doing with our various things in Docker Compose. That being said, let's take a look at how to do that right now. Off the video, I added Git into our project here. That is why we have some of these new files in here. I'm not really going to be talking about it much other than now to let you know, of course, all of the code is available on GitHub. You can always grab this on cfe.sh/GitHub for the Django IoT with TimescaleDB series. And the rhyming was not intentional, but it did happen. So now what we want to talk about is further isolation, and that is by using something called Docker or containerization tools. Now, in our case, we are going to be using a containerized version of TimescaleDB on our local machine so we can actually get everything working correctly. Now, there's certainly a way to install Timescale on your system at large, but what that does is it requires you to set things up in a very specific way when you want to reuse it for a new project. We want to make it so we don't have to do that. We want to make it as straightforward as possible while also providing references on GitHub if we ever want to spin this thing up again. So what we're going to be doing is in the root of our entire project here, we're going to go ahead and create compose.yaml or YML. YAML with the A is how I prefer to write it. I'm not sure why. But the idea here is we want to declare everything related to this particular TimescaleDB that we want. So what we're going to do here is we're going to declare something called services. We don't need a version anymore. Docker Compose has changed over the years, for those of you who are familiar with it. We want to name our service something. In this case, I'm going to name it literally TimescaleDB. Now, we'll talk about these services later, but for now, I just want to declare the image itself, and this is going to be in timescale and then /timescaledb : latest django-pg16. Okay, so how do I know what this is and where can you find other images that are related to this? So just keep in mind that this service name is arbitrary. It's a variable. We can change it as we see fit, whereas the image name is not arbitrary, nor is the definition of image. So how we find these things is in a place called Docker Hub. So hub.docker.com. If you go here, you can find all kinds of open source images that you can use. In our case, we actually are using, of course, the TimescaleDB official image from Timescale itself. And then if we look at our tags here, we can see the different tags that you might want to use. You can use older versions of Timescale as well. In our case, we want to use Postgres 16, which just happens to be the latest release. But I think a lot of these older ones will still work. You just might need to change some of your Python dependencies and requirements. Like scicopg, the actual version 3, this works with the newer versions of Postgres, which is what, of course, Timescale is built off of. So if we just left it like this, that would be fine in general. But of course, on Docker Hub, what we can see is we can see different documentation, different options that you can do for actually using this self-hosted version of Timescale using the pre-built container. And so there are a lot of different options in here that you could go through, and I'm sure there's even more to come. But what I want to do is just give you a lot of these options. Now, the first thing that I want to do here is I'm actually going to go ahead and declare some environment variables. Now, these right here are not great, right? So your username, your password, your database, not great at all, but it will help us inform things later when we actually want to get this thing going. So those are the environment variables. We'll see this again in just a moment when we need to modify it. Then we declare ports. So what we've got is, it even shows me host port, container port. So by default, all Postgres runs on 5432. So what you could do if you wanted your local machine to have access to this actual container itself, you can actually do 5432:5432. This means that I'm going to have something like my local host 5432 that will allow for me to actually access this TimescaleDB. But of course, this now blocks the default port for your entire system, right? So the default port is maybe not something you want to block. So in my case, I will do the movie equivalent of hiding numbers and do 55555 and just use that as my new Postgres port. That's it. So what we have right here is building towards using, let's say, for instance, our .env.web, using our database URL being something like Postgres SQL or PostgreSQL, then / your username : your password at localhost : 5555 / your database. So this is now our connection string that we have based off of this configuration. So it's not using the default port. That default port will be running with this container itself, but it will not be running on our local machine because we declared 55555 right there. Next up, what we want is to have some data here. What I'm going to do is I'm going to bring in a volumes declaration for Timescale data, which I'll do in just a moment, which will map to this location. So what I can do then is actually just come in here and say volumes is equal to that volume. So whatever's happening right here needs to be right here. This is by far the easiest way to go about doing this. And then the next thing is whether or not we want to restart this. This policy means that it's just going to restart this service unless it is stopped directly. Now, a lot of this is maybe confusing in terms of if you've never used Docker before. If you've used Docker before, you'll realize that compose.yaml is just a way to maintain what's happening within any given container. So instead of running like something like Docker run with all of the arguments in there, compose.yaml just keeps them for us. So you can even see this in the documentation. There are just simple Docker run, Docker poll, all of this stuff. Docker compose just makes it so we don't have to write all of those things over and over and over again. We just leave it right in here. So I'm going to go ahead and save this. And now I'm going to go ahead and instead of Docker run, we'll do Docker and compose. I'm going to do -- version just to show you what I've got, or rather not -- but rather just version. There's the version I'm running. So it's Docker and compose using Docker desktop. So of course, all of that available once again is in Docker docs. You need to download Docker desktop and just run that Of course, it has this Git Docker in a lot of different places on how to install these things. There's too many references to go through right now. But of course, if you search online, there's a lot of different easy ways to install Docker Desktop. And once you do, you'll see something along these lines. Like this is Docker Desktop itself, and you can see all of the different images and volumes you might have. The complexity is huge if you want to go through that whole process. I don't want that to happen for a lot of you who are brand new to this. I just want you to realize this is just basic configuration to make sure that we can run this database at any time, or really this container image at any time. And we can run it over and over and over again across all different projects, assuming our system is big enough to be able to run all of those things. This can be used in a lot of different places, which is why it exists. In other words, if you're on a Windows, Linux, or Mac, I can send you this Docker Compose file and you can run it the same way I am. That's the key part of this. And when it comes to installing Postgres or any sort of image that's not already on your machine, you might need to do a bunch of other installations just to get to the point where Docker containers work out of the gates. So what we want to do here is we want to run Docker Compose up. This will actually download the image itself. So we see that it's pulling the image itself right here. Then it's going to go ahead and allow for me to run these things. So when I run Docker Compose up, it pulls the image and then it runs the database. If I were to close it out with just Control-C and then run it again, it's running that same database. The reason it can run the same database has to do with the volumes and the data that are in here. So you can absolutely remove those things as well. That is definitely in the documentation quite a bit, and Docker Compose just gets better and better over the years. This process was always fairly straightforward, but the idea here is if I do Docker Compose PS, I can see all of the containers that are running on my particular project here. And so there we go. We've got our localhost 5555 that's going into the container, which is running a version of the actual project itself, 5432. So the container is running, but then inside of that container, it's also running something else. So it's kind of running two things. If you think of containers as like a small little operating system, you're on the right track. So we ran that operating system, and then within that operating system, it's running a version of TimescaleDB. The thing is, it's not a massive operating system. It's really small and as efficient as it possibly can be. And so you can also inspect all of these things inside of Docker Desktop itself on how big all of the container images are, where they're running, and all of that. So we can see the TimescaleDB image is 0.5 gig, which is not too bad. In conjunction with some other things that are out there, there are definitely bigger tools that are out there in terms of the size of a container image. But this is a full-on Postgres database. You can totally use this in production, although I don't recommend it because of how easy it is to bring it down. So Docker Compose down, and then something like --rmi all, this can remove all sorts of things, including the network, the container, and that also may delete a bunch of your information. It's really just that simple. You bring it down, you bring it up. It's really, really nice. So we are going to be using Compose a lot to really highlight what you can do in terms of time series with TimescaleDB. The only reason we are talking so much about Docker Compose is for that, because we are going to build our container image based off of our code, and we will have multiple instances of it running. So getting this right is critical. If you need some stuff on Docker Compose and you need some recommendations on where you can learn more things about Docker or Docker Compose, let me know in the comments. But also on my website, I've got some stuff, quite a few things related to Docker and Docker Compose. So yeah, let me know if you have any of those questions, because right now is the critical part when you're going to want to know how to do it, because going forward is really going to be about scaling this thing up. Now, once we actually bring it into a more production use case, we will stop using Docker Compose and use cloud-based services to ensure all of this works, including TimescaleDB's cloud version. So if for some reason all of those things are falling apart, you can go forward into what we do with the cloud versions in this series so that you can just use that going forward instead of Docker Compose, because this is certainly not a requirement to make all of these things work, but it is a really low stakes way of testing out how to do time series across multiple distributed versions of Django. Now we want to go ahead and integrate our Django project with our TimescaleDB through this database URL. This is going to be a very straightforward process, but as it stands right now, the way our database URL is configured, we are actually leaking the credentials on our GitHub repo. And of course, the reason for that is because those are hard-coded into the environment variables. Generally speaking, you don't want this to happen. You want it to be not hard-coded into Docker Compose, but rather using something like an env file with a specific file name. Very similar to like what we did with our Django project. So what I'm going to do here is I'm going to create another one with .env.db. This one I will commit to Git just as an example, but realistically, if you were doing this even in your local environment, I do recommend not sharing this on GitHub and making it as secure as you can locally within the context of what we have right here. So what do we actually put in .env.db? Well, it's all of these arguments right here. So we can bring this in and we're going to go ahead and do our Postgres user. We're going to change it to being equals, and we're going to get rid of any spacing that's in there, and that's going to be true with these other arguments as well. So just getting rid of the spacing just like that. Then what we want to do here is instead of your underscore, I'll just go ahead and do a search and replace and do local underscore. Not a huge change, but one that is enough of a change that it is at least different than what's being committed to Git. Again, env.db will be committed to Git in just a moment. So now that we've changed the environment variables, there's a few things that we need to do. Of course, in compose.yaml, we need to reference that database file in the env declaration block here, just like that. Notice that it has a dash here. This means that I can actually have multiple environment variable files for any given service inside of Docker Compose. That's super nice. Now, what I want to do is, now that I've got this all situated, I'm going to go ahead and run Docker Compose and down --rmi all. I want to refresh all of this. I want actually to take down everything that already existed and refresh with my new environment variables. Yes, there's a way to change the password after it's already up and running, but that is definitely outside the context of what we want to do here. What we want to do is just use the right password from the get-go. Notice that I get this warning of the G variable is not set. So this is actually a characteristic of .env files and the way Docker Compose loads them. It loads them a little bit differently than Python does or Python Decouple does, but the idea here is our .env files, we need to make sure that they don't have unescaped $signs. So in my case, I actually do. It's actually a nice error to see. So if I actually look in here, if I do a search for a $sign, I'll see that I've got $G and also this one right here. So if I just get rid of the $signs altogether, that error should go away. Now I might need to do it in multiple places because of how the environment variables might be loaded in. And so that's that. There we go. Okay, so now if I do Docker Compose down, I shouldn't have that error. There's a really good chance that you never had that error in the first place. So with this in mind, I'm going to go ahead and now do Docker Compose up. Now what it's going to do once again is pull down the image itself. Now one of the commands that I didn't mention before has to do with the volume also. So Docker Compose.yaml, this volume right here. So rmi -all will actually take down old images, which is why it actually rebuilt the image or repulled the image. This is not something you'll need to do all of the time. Realistically, if you need a fresh database altogether, what you'll need to do is something different. So what we see here is after I run this up, it says it already appears to contain a database. This is showing me that it actually has the original database data. In other words, the old password and username and all that. So what I want to do then is close this out with Control-C and then clear this out and just do Docker and Compose down -v. -v will take down the volume as well, as you see right here. This doesn't remove the container image. So now when I actually run Docker Compose up, the image is still there. It just actually spins up the database a lot faster and it goes ahead and initializes that database. When it's doing that initialization process, it actually will create that username and password in there from this env file as well, which is something we want to test at this point. So with this in mind, in env.web, once again, we want to change your underscore to just simply local underscore. Not that big of a deal in terms of the change in passwords and all that, but now our environment variables have changed enough for our Django project. Now, I also want to actually bring this web into my actual, GitHub repo, and I'm just going to call this sample, mostly so that you can reference it in the future. Of course, those passwords are now still being exposed, but the idea being that if you were to get rid of the sample and the .db, obviously they wouldn't be exposed then from compose.yaml. Great, so with this in mind, I'm going to go now into my Django project, into settings.py, and I want to implement a few things. So now underneath databases here, this is actually where I'm going to declare my database URL. Now, you may have seen me do this already, but the big difference between doing it this way, as in other projects, maybe you've already seen me do this configuration here. Now, what I want to do here is I'm going to go ahead and cast it as an src or an str, and the default being an empty string. Right. So basically, if the database URL is here, then we'll go ahead and run if database URL. This is where we're going to go ahead and import the DJ database URL, and then I'll go ahead and declare my new database configuration for default from the DJ database URL .config, and saying the default equals to that database URL itself, just like that. And then we can do our connection max checks, or connection max age actually, and I'll just do 600. There we go. Okay, so what's happening here in terms of the configuration, we also want to make sure that it is, it's not equal to an empty string here. We just want to make sure that it exists and it's not an empty string. If it doesn't exist and it is an empty string, it's going to go based off of this database itself. So this configuration, what's really nice about it is it's using the connection string itself. I think this is the way to do database URLs, especially in terms of Python projects or even Node.js projects. There's a lot of different ways on how you can think about doing this, but having this one single connection string is super nice. You can always decouple these things if you wanted to, which will require additional settings for the Django database URL configuration, which you can actually find on the Django docs. So if you do Django docs, database, Postgres, something like that, what you'll find in here is a bunch of things related to how to configure your Postgres database, including other kinds of configuration in here as well. So there's definitely a lot of different ways on how you can, configure Postgres to work on Django itself. But doing this is just the simplest way to do it. Okay, so now that we've got this, we've got our database running, we've got Timescale running, I'm going to go ahead and run my Django management commands. So we'll go ahead and navigate into src here. We will run python manage.py migrate. Now, this works just fine. It actually did migrate the database. Let's take down the database by doing Control-C. This stops that database. I'm going to go ahead and try to migrate again. This time it says it did not perform anything. So I've got my db.SQLite 3 here. So in other words, my database is not actually connected just yet. So let me go ahead and migrate again. Once again, it creates db.SQLite 3. So this is part of the reason our database URL has the casting of making it a string and the default being not equal. In other words, the db.SQLite 3 is my backup database, but it's also showing me that my configuration is wrong somewhere. My sense is it's probably related to the configuration itself. So if we go into helpers env.py, what we can see here is all of our .env files. Let's go ahead and just check those paths themselves. So I'm going to go ahead and print each one out where the paths exist. Save that, and we'll go ahead and run migrate again. It shows me all of the different paths. All three of them have src in there, which means that I actually used the incorrect one. So the actual repo dir is what I should have been using for the repo dir env and repo web env. So just changing that slightly. Now if I were to run migrate, once again, it should actually connect to my local project, assuming that it is running. Let me go ahead and bring it back up, and we'll go ahead and run the migrate again. There it goes and migrates. I try to migrate again. No, it doesn't work. I go back into Docker, I bring this down just with Control-C. I don't need to remove the volume. I go to try to migrate again. Boom, it actually now does not connect. So this is definitely showing me that it is using the Docker Compose version of it all. So I can go ahead and delete out the SQLite database itself. So also all of the print statements for the locations for those different files. The other part about this that's important to note, that anytime if you ever run the migrate command and it actually does migrations, that means you're probably using the wrong database. This is also going to become very clear as to when you are using Django itself, but if you were to run migrations or it's saying, hey, you have unapplied migrations, let's go ahead and see what I mean by that. If I wanted to take a look at unapplied migrations, I could just come into the settings here, and we'll go ahead and just comment this out for a moment, and then we'll just run python manage.py run server. What I'll see is this unapplied migrations. This is showing me that I actually am using the incorrect database. So db.sqlite is not what I want. Now, I'm showing you all this because the other important part of using the Docker Compose to really just get a sense as to what's going on, you will want to take it down from time to time and completely delete everything and start anew, start fresh. We'll probably see that again, but generally speaking, the idea here is rapid iteration, constantly be testing things out with our different database setup and all of that. And if you do it correctly and you test things out correctly, you should be ready to actually start ingesting time series data using Timescale, which we want to do right now, at least generating some fake data. Let's take a look. When it comes to storing time series data in Django, you could do something like this, where you actually have a timestamp for each entry you put into your database. This is actually very straightforward itself. But the problem here is it's not made for time series. Yes, it is storing a timestamp itself, but it's not optimized for time series at all. So what we want to do, of course, is have it optimized for time series data. That is, of course, data that changes over time. This metric class that I created here is a good example of that. We will be implementing this quite a bit throughout this project. This is going to be the baseline model that we'll be using. But instead of actually declaring a timestamp ourselves, we're going to be using the Django-TimescaleDB package to do that for us. It will do the heavy lifting for us, and it will allow it to be automatically integrated into our TimescaleDB database. So what we see here is the quick start is fairly straightforward. We install the Django-TimescaleDB package, which we actually should have already done. So if we actually look into requirements.txt, there it is right there. So we already have that done. The next part is the actual TimescaleDB engine. So this is a different database engine than we actually have. So we actually want to make sure that we are adjusting our settings to account for that. So inside of the database URL portion, this right here, we absolutely can pass in our own custom engine here. So the way we do that is just by grabbing this string here and pasting it in just like that. Not a big deal. However, I have now potentially changed things related to the migrations, which means that right away I should actually go into my database itself, close it out, and then do Docker Compose and down -v, take down that volume, and then we'll bring it right back up where it's going to go ahead and create everything anew. And then I'll go ahead and run my migrations once again. And we'll just do python manage.py migrate. This should change that database entry. I don't think there's going to be a lot of things that are obvious as to what's changing. In fact, it might not do anything because of the actual Docker Compose container image that we're using. But the point is, we're going off of their documentation, and we want to make sure that that documentation is followed as closely as possible to set ourselves up for success in using this time series data. So the next part of this is to actually scroll down a bit, and we can inherit from the timescale model, which means that a hypertable will automatically be created. Hypertables are, the class for actually using the time series data. It's what modifies the actual Postgres table to ensure that it is time series data and it is optimized to ingest a ton of data and also allow us to do aggregations later for that data. So the idea is this is now our default class, a default model that we'll end up using. So like what I just showed you, this one right here, we could abstract this out. We could say something like class meta and then do the same thing where it's abstract being true, and I can get rid of these things, and then this would be my time series. But again, it's not necessarily optimized for making everything work on the actual TimescaleDB project itself. You totally could, but in my case, I'd rather use a managed package from members of the TimescaleDB team that are making sure that this thing is working well. So the idea here is it's actually not that complicated of a package. It's actually fairly straightforward, but of course, I'm not going to use this example anymore. I'm going to go ahead and create it from scratch. So now let's go ahead and do that with our Python manage.py start app, and we're going to call it sensors. So I'm just calling it sensors to encapsulate the idea that this particular app is going to be responsible for capturing sensor data, data from like a Raspberry Pi. That's kind of the idea here. So what we want to do then is grab the models in here and declare our model. Now, of course, I can actually just copy and paste directly from their example here of metric, and that's actually what I'll do. I'm going to go ahead and copy this right here, and I'm going to paste it into my project here. So it's still a Django model. Once again, we can look at the actual code itself. It's still inheriting from Django models itself, but now it has a bunch of things related to timescale specifically and the various intervals and a bunch of different configuration you might want to go about doing things with. But in our case, we don't have to write a bunch of new code here to make sure that that's working. One of the things I do want to add, though, is something for a node ID. So if I do models.integer field, I'm going to go ahead and default this to simply 0. This is going to be coming into play much more later, but for now I've got a way to just start storing my different metric data. So of course, just like any other Django app, as soon as you want to add it into the database, you need to put it into our installed apps here, in which case I will do that with sensors right here. Then I'll go ahead and run my Python manage.py make migrations. I made some changes to the models.py, so I run make migrations, and then Python manage.py migrate to make sure that that's in there and working. Now, another thing that we want to do is inside of the Django admin, I'm going to go ahead and register this one. I'm just going to go ahead and copy and paste things here for it with our list display, our node ID, the temperature, the actual field that they gave us, and then the time field, which is also given to us by the package itself. So I'm going to go ahead and save that, and since we have this up, I'm going to go ahead and do create super user, and I'm going to use a whatever username and a whatever password, mostly so I can just access it locally and make sure I give it the correct password each time. There we go, and I'll go ahead and run the server now just so we can see what it looks like for instances of the database model. So I'm going to go into the admin here, and I'm going to type in my username and password, go into those metrics, and we're going to create a new metric here. The time, I'm not going to go ahead and, maybe I actually do need to set that. We'll go ahead and see in just a moment. I'll do 99.9, save and continue. It does require me to add this in the admin itself. We'll see that in just a little bit later. But there we go. There's time series data. It's not that complicated, but the idea is how we're going to go ahead and approach this and ingest a bunch of data, then do some aggregations as well, which is pretty neat. Now, of course, we can do all sorts of things that you can see inside of the documentation for the Django TimescaleDB package, which gives us a lot of other information that we might want to go about checking as well. But for now, I'm going to just leave it as is, and we actually want to start creating the process as to when we can actually have a bunch of test data to start out to see if we can just fill this thing up with what would be distributed Django. The way we're going to do that is by implementing Celery as a worker process for a bunch of different reasons, as we'll see. Now, as you may know, Django itself lives in the request response cycle. You as a user, you go to a Django-powered web page, Django takes in that request, does something to it, and responds. And it usually happens really quickly. Maybe it's a maximum of 5 seconds that Django runs to return something back, but usually it's a lot faster than that, significantly faster than that. So the idea here is Django is really good about the request response cycle. Now in there, of course, it has the Django ORM. You can actually use a lot of the built-in tools to store data, and that obviously has some implications for that request response cycle. But what Django doesn't do is take long requests or requests on a regular basis. Let me rephrase that. So if you actually needed to run a function every day at a specific time, Django doesn't do that. If you needed to have a function run super long, Django doesn't do that. In other words, Django shouldn't do that. Now, there's a lot of different ways on how you might approach making that happen in Django, but I think one of the best ways is by using Celery. So Celery is a Python-based task queue. So Celery doesn't need Django to run, Django doesn't need Celery to run. But as soon as you integrate the two, you have a powerhouse that leverages all of Django's great strengths, one of them being the ORM. In other words, one of them being Django models. The way Django handles the database interactions, queries, all sorts of things is fantastic. So we actually can run Celery alongside of Django and leverage all of the models that Django has. We don't need the views or the templates or the URL routing. None of that stuff is necessary to actually use Celery itself. And so the reason we actually want Celery in our case is the fact that actually our project, when it comes to running it on a node, whether it's a Raspberry Pi or some other machine, as soon as we want to start distributing our Django project, the way we distribute it is through Celery. Yes, of course, that's because it's removing it from that request response cycle. When we want to remove it from that, that's when we use Celery, and we use a Celery worker process for this or a beat server for this. So Django itself can be distributed in a different way. So if you wanted to actually have something called load balancing, if you wanted to handle more requests and more responses, you would do something called load balancing where you're running multiple instances of Django itself. But if you wanted to handle different kinds of functional data, in our case, collecting sensor data, you want to use something like Python Celery in conjunction with Django. So Celery is going to use all of the Django stuff. It's going to use the same database. It's going to be distributed in a very similar way that you would with load balancing requests, but instead it's going to be load balancing your offloaded functions. It will actually redistribute your offloaded functions using Celery. So this is what we need to set up. It's a really powerful way to do it, and I think overall, especially when it comes to once you have some of the configuration down, actually scaling up Celery, I think, is a lot easier than scaling up Django. Neither one is really that challenging, but Celery itself has a lot of really cool built-in features to have a lot of different instances that can run alongside of each other, a lot of different worker processes that can then just move around. So in order for this to work, we actually need to implement a data store for the messages that are going to be shared across all of the worker processes in the actual Celery instance itself. In other words, Celery sort of needs its own database to know when to run things and when not to run things. We probably could use Postgres for that, but what we end up using is something like Redis. Redis is a little bit better suited for task queues or distributing messages than something like our Postgres database. Postgres itself is much more for long-term storage. Redis is for short-term storage that goes a little bit faster. So let's go ahead and go through the process of integrating Celery with our Django project right now. It's fairly straightforward. There's a lot of documentation on this, but the idea here is we need some baseline setup to make this happen. Back into our project, we're going to go ahead and go into our compose.yaml file here. We're now going to make a service for Redis. So the image itself is Redis latest. Then we want to go ahead and declare the ports we're going to go ahead and use for this one. In this case, it's going to be 6555, and that's going to go to 6379, the default port itself. And let's make sure that this is a colon. And then we also want to go ahead and declare our volumes in here. And this is going to be our Redis data going to /data itself, just like what we did with our volumes for Timescale. And I'll go ahead and use an underscore here to follow along with Timescale. And there we go. So now we've got our Redis data. This, of course, will give us a Redis database itself. So for my Docker Compose, I can just hit Control-C, close everything, and then do Docker Compose up. That will bring up a Redis instance for us. So what this allows me to have, of course, is then going into env.web, I can now say that my Celery broker, the Redis URL, is equal to Redis and //local host. Now it's 6555, and that should be it. Maybe /0 for the default Redis database itself. Okay, so now that we've got this, let's go ahead and start the process of integrating Celery itself. Now, one of the things we definitely have is the requirements have Celery and Redis in there, and then we have a few other things related to Celery itself. So the first thing that I want to do is inside of my main configuration, wherever settings.py is, more specifically, if you look in manage.py, you can see that we've got this OS environment, Django settings module, CFE home.settings. Whatever that is, that's where you're going to want to put this. And so we're going to go ahead and create our Celery.py here. And we're going to go ahead and implement a few objects. I'm just going to go ahead and copy and paste them and give you a reference where you can learn more about this. Now, first off, if we go into cfe.sh/blog, what you will find in here is going to be under popular. There's going to be most likely Celery, Redis, Django. This guide, I've updated it many times, so feel free to go through it if for some reason what we do right now is not going to end up working for you, but it should work really well because this is actually a really critical integration. The Celery docs also has stuff related to Django itself and other frameworks probably, as you see here. But overall, I really like using the Django version, of course, for all of the things I just mentioned. So what I did here was I set up the environment variables, the same exact one from the actual manage.py command. This is the same exact OS environment default for the actual module itself. Then I declare the app itself, which is going to be based off of that module as well. And then I've got my related configuration in here from here. Next up, what I want to do is go into the init file here, and we'll do from.celery. We're going to import app as the Celery app. And then I just want to bring this out as all. So all, and here we go. And then our Celery app. Great. Next up, what I want to do is jump into my settings, into my installed apps. I want to bring in my Django+Celery beat and Celery results. Every once in a while, this doesn't support the latest version of Django, which is also another reason why I went ahead and declared these right here. I believe they work for this Django version right here, but usually when Django's updated, these might lag by a month or two to make sure that those are working. That also might not be true in the future, but it has been true in the past. So I'm going to go ahead and now scroll all the way to the bottom and do some default configuration for Celery. The very first one is going to be our Celery broker URL. And this is going to be equal to, well, config of that Celery broker URL. So this one right here, just like that. And so the default itself, we could put to the default Redis instance, which is Redis//localhost of 6379. That might be the right default for you. Next up, what we want is the Celery result backend. And this is going to be equal to our DjangoDB. So we want to store the Celery results in the Django database backend, which of course will be our TimescaleDB. It is not optimized for that. Celery, Redis, and Django do not have the TimescaleDB optimized yet. Maybe at some point it will be though. Next up, what we want to do is we want to bring in the beat scheduler from the Django+Celery beat package itself so that the database itself can actually manage various schedules to it. This is optional. It's not necessarily something you want to do at this time. And then a few other default configurations I'll have in here just like that. Now you can always look these things up in the backend itself, but some of these are newer and things you're going to want to have, like the Celery Redis backend use SSL. We want that to be false. We don't have that set up at this time. Maybe at another time we will, but now we should have everything configured. So while I didn't go through all of these configurations one by one and type them out, you can always look at the documentation to see exactly what's going on. But this is now the baseline that I've seen that works really well for Celery and Redis. So now what we want to do is just verify that this is working by doing running our Celery command right next to manage.py, just like we were running the Python manage.py run server, right? So it's very similar to that. But we just do Celery-A as in app CFE home. Now the reason this works is, of course, the CFE home folder or module has an init method with the Celery app in it. That's why that works. From here, we can call a worker process with a log level of info. This should actually allow us to see what's going on. The key part of this is the actual transport itself, or that Redis, that local host is actually there and it's actually working. So we actually do have this. We have no tasks yet. We will bring those in just a moment. But the point is I can actually run that same command again and again. I can run multiple workers for this entire process. This is something that we can do and we will do in the future, in the very near future, as to how we actually can distribute tasks against a bunch of different brokers. We can also do something called a beat server, where it's basically the same thing. Let's go ahead and close this one out here. It's the same thing, but instead of it being worker, it would be beat, just like that. And so the beat server is something that we still need to actually work with by doing python manage.py migrate, and this will allow us to run that beat server. So at this point, we now have Celery integrated. It's just a matter of creating a task to actually collect fake data to start. Now we're going to create a Django+Celery task to generate fake data that we can bring into our TimescaleDB. The idea here is Celery.py, our main configuration, has auto-discover tasks on here, because if it doesn't, then of course it's not going to work correctly. Inside of our Django app, we're going to go ahead and do tasks.py. I'm also going to go ahead and create something like collect.py. And so collect.py is going to go ahead and do our random number. So I'm going to go ahead and find get random, call it random temp, something like that. And all I'm going to do is return the random.uniform 0.00 or 0.0 to 130.0. So this is in Fahrenheit, of course. Of course, you could always change it. The idea here is it's a number in between a range, which will generate a float number for us. That's really the key there. Next up in task.py, we're going to go ahead and import from import collect. And let's go ahead and do it just like that. Next, we're going to go ahead and import from Celery, we're going to import our shared task here. And I'm going to define, let's go ahead and do shared task, the decorator. We're going to define the measure temp task. Okay. And so by default, we're going to go ahead and give the temp being collect.getRandomTemp, right? So at some point, maybe we'll change this to get actual temp or get sensor temp or something along those lines. But for now, this is just fine. And so the question is, of course, where do we store this temperature? How do we actually store it into our database? Well, there are many different ways on how you could think about doing this. One of them is you could do from.models, import the metric itself. That is certainly one way you could make sure that you are bringing in the model class itself. But what that prevents us from doing easily is using this task inside of our model. There is a potential that you might want to do that. So typically for me, when it comes to Django+Celery tasks, I do not import the model directly here. Instead, I import it into the task. I'll explain why in just a moment, but let's go ahead and do that with from Django.apps. We're going to import our apps here. And then the metric model is equal to apps.getModel. And then the app name, in our case, it's sensors. So sensors, or rather the app label as it says is the argument. And then the model name, which of course is simply metric, which is this. Great. So this will now give us that exact same model. Now the big part of the reason to do this, in addition to allowing Django models to call at any time, you have to remember that the Celery task itself, the one that's going to run this task, is a separate process that's running outside of Django itself. So this works totally fine. And it's not in the request response cycle at all. So this should also work just fine as well. But it really allows us to call it inside of models.py. If you had some sort of post, let's say you wanted to do it in our save method here, you could do something like that. That would be one option you would be able to do. I'm not going to implement it, but it is something that I think about every time I define a Celery task. So now we've got our metric and our temperature. The next thing that I want is my actual node ID. Now, the way we're going to get this is from our main configuration. So to do this, I'm going to go ahead and import helpers here. And we just want to call helpers.config and then the node ID. This is going to be an environment variable, but by default, I'll go ahead and say 0. This default, of course, is the same default we set in our integer field. It doesn't necessarily have to be set in the integer field, but if it isn't set anywhere, you definitely want to set it right here. The reason for this is how we're going to distribute it later. Each actual instance that's running Celery will be on a different node. It'll have a different node ID because it will be distributed. Different machines will be running this Celery version. So the idea then is, now that we've got that, we're going to go ahead and do metric.objects.create. The two arguments we definitely had, which is our node ID here, the next one being our temperature, and that's going to be our temp right there. Of course, that's going based off of this field right here, right? Make sure that's correct. And then the next one is going to be our time. So to do time, we're going to go ahead and do from django.utils. We're going to import our time zone. And I'm just going to go ahead and do timezone.now. And there we go. So there's our task to create and measure our temp to make sure that this is actually working. First off, we need to make sure Redis and Timescale are still running in Docker, of course. Next, what I'm going to do is run celery-a, and this is going to be CFE home, worker, log level info, and hit enter. What we should see is that task come up, right? So that's a key part of this, making sure if that task is not there, if this is an empty block, then of course we did this part incorrectly. Next thing I want to do is I'm going to go ahead and run into the SRC. We're going to run python manage.py shell, and then I'll just go ahead and do from sensors.tasks. We're going to import all, which will allow me to use the measure temp task, and then we can do .delay. Delay turns it into a Celery task. If you just call it directly, it will run the task as is. It's going to run it like a normal Django function. If we call .delay, this becomes an asynchronous function, as in it gets sent over to Celery to run. And assuming that we have Celery running, we will see that it does run, and it runs in a short amount of time. So what I did was, of course, I actually measured a few times. And if I were to run this several more times, it of course would actually save these things several more times. So if I were to run Django now, so let's go ahead and run the server within python manage.py run server. And then jumping into the admin, we can see the different metrics that are coming through in here with that different node ID and a random temperature between that value. Now, this temperature, of course, is not really that accurate because realistically, you're not going to go from 17 degrees to 120 degrees within half a second. That is probably impossible unless you're flying really close to the sun. Now, in our case, we are definitely not doing that. And of course, even that logic was flawed. But the idea here is that we can actually collect this data, and I can continue to run this as well. And of course, it's updating our database as we see fit. Now, those of you who've done Celery before, this is not anything surprising to you whatsoever. But the new thing that might be is this node ID here on how you could go about changing that. Now, one of the ways we could change it is, of course, by going into our environment variables and doing something like node ID and changing whatever that value is. Then going into our Celery worker, where the task is actually going to be executed, not where the task is created, like the Python shell. This won't do it. It will be on the environment variable of where the task is being executed. So now if I close down my Celery worker here, run it again, what I should have is that environment variable updated, right? So it actually should go based off of this. Let's go ahead and give that a try by going back into our Python shell, import those sensors, delay it a few more times, and then just take a look in here. Now our node ID has changed based off of the worker that's actually doing the temperature reading. In other words, it's now prepared to be distributed in different ways. It just needs to be changed based off of the environment variable itself. Now, there are more advanced things we need to do with Celery directly, but this alone is enough. This alone, it allows us to do all sorts of really cool things with the different nodes themselves. But of course, we want to make it a little bit more advanced so that things don't overlap too much, especially when it comes to our schedulers, because that's what we actually really need to do next. So far, all we've really been doing is not too dissimilar from the request response cycle in the fact that I'm initiating this. I want it to be scheduled and run on its own, and we can do that directly in Celery. So let's take a look at how we can auto schedule different tasks to run. Let's go ahead and create a schedule that Celery can follow automatically to run our tasks for us. Now this can be done in the Django admin, but the reason I'm going to do it hard-coded inside of Celery.py is really so that I can prepare it for additional nodes that I might be deploying with Celery. So we'll see that as well as we go forward. The idea here is we want to define a Celery beat schedule dictionary that we're going to go ahead and fill out. This is going to be done in Celery.py, of course, where we configure the main app, because we're going to go ahead and do app.conf.beat schedule, and we're going to set it equal to this dictionary in here. So the idea is we need to give it a name. The actual task itself, or the scheduled task, needs to have a name. In our case, we'll call this our check temp name itself, and then we can add in a bunch of different parameters in here related to this task. First off, we declare the task itself. This is going to be using string and dot notation to the actual task itself. Now, the idea here is we grab sensors. This is the app name, so it's going to be in the sensors module dot the tasks module dot the actual name of the task, or the function itself, which of course is the measure temp task. It's really just that simple. Then we can go ahead and declare our schedule. Now, by default, I can actually declare seconds. So if I wanted to come in every 5 seconds, we can do that just like that. If I wanted to be every half second, I can do 0.5, and that's going to be every 1/2 seconds, which might be what you want to do with temperature. Now, you might want to do this more often as well. It's really going to be up to you on how you go about how often you need this to be tracked, how often you need new temperature data. Like I said before, you can actually trigger this as a one-off inside of the Django admin, in addition to scheduling it as well. Once again, another reason to use Django itself. But now that we've got this, we have a little bit better of a schedule process that can run. But the thing is, how do you make sure that this is working? Up until now, all we've seen as far as the scheduling tasks is, if I hit Control-C to close it out, I see that it is worker like this. Right, so all we've seen so far is simply worker. But if I want to run the beat server inside of Celery, I change worker to simply beat. That way it will run all of the beat schedules, everything that's stored in the schedule, how everything's configured in your Django project. This also means that it will use the database scheduler as well. So if you do schedule things in the database, this beat scheduler will work. Now we can actually run both of them at the same time. We can run a worker and beat with that right there. So it does both things at the same time. So it's really up to you on how you want to go about doing that. I actually really like doing worker and beat, unless of course my beat scheduler needs to be massive and it needs to do some really interesting things. So as soon as I do worker and beat, I still see that these sensors are in here, and then I also can see that tasks have already started going. They started flowing already. And so what I want to do is I want to look into the Django admin, and let's go ahead and make sure that that is running in here somewhere. And I'll go ahead and run that server. We'll refresh in here. And now I'm seeing a lot more data is now being ingested. Of course, it's happening every second, so it's just going to continue happening. Timescale is designed to handle this kind of ingestion. It's going to end up being a lot, and so just keep that in mind, especially with something like every half seconds. Now, this is going to be exponentially more as we add in more nodes. Once again, Timescale is designed to handle those things, which is super cool. But of course, before we even get there, I'm going to just change this number to being every 5.0 seconds, just so that I'm not overloading my local system while I'm building this thing out. To make that schedule change, we just save it, and then I just need to restart the server, the actual worker process itself, and make sure that that finishes out. Now, this still might have a few tasks from before. That is where Redis comes in. Redis will keep track of those things for us. So if any of our worker processes go down, Redis will make sure that we bring them back up and do those different measuring temperatures itself. Cool. So that's a really simple way to do tasks. Naturally, we can have more of these, and we could call the same one. That is something we will take a look at in here in general. But of course, the name for the beat schedule itself needs to be unique. So if you were to do the exact same thing all over again, you just need to make sure that the name or the key inside of the beat schedule is different than other ones. That's it. Great. So now that we have this, we need to think about the process of how do we do it based off of a specific task queue. Right now, it's just the general queue itself, the default one. We want to actually have specific queues for specific nodes. In other words, the first node needs to be in the first node queue. The second node needs to be in the second node queue, and so on. And then we want to make sure our beat scheduler is adjusted to that, to those different queues. This is probably complicated to just talk about, so let's see how it's done. Let's say, for instance, I have 3 Raspberry Pis that I want to be part of our distributed Django+Celery system. Each one of these Raspberry Pis will be a Celery worker, not a beat server, but a worker. Now that worker itself should have its own task queue. In other words, Raspberry Pi 1 should be doing all of the things designated for Raspberry Pi 1. Raspberry Pi 2 should do all of the things that are designated for Raspberry Pi 2, and so on. So what this means is we actually can use something called task queues inside of Celery. Now this can actually get really complicated, so I want to make it as straightforward as possible so you can really just see how this ends up working. So now what we're going to end up doing is we're going to be using just simply Celery worker beat for that, and then for all of our task queues, which we will do in a moment, we will do worker and then -Q and then what task queue it's going to be. The first one, we'll just go ahead and say node 1. So let's go ahead and do this now. We're going to do a couple different servers here. I want to close out everything that's running with the exception of our Docker Compose stuff and maybe our Django server running. Okay, so now I'm going to go ahead and run our beat server. So we only need one single beat server because it's really handling the schedule itself. We don't need anything beyond that because the workers themselves will start to look for things. As soon as we just run the beat server, we can see that it's sending tasks based off of the schedule that we created for every 5 seconds. So we can designate this to be based off of a task. So if I did a comma here and then passed in some options, so we're going to put some options here and basically pass in the queue as a dictionary here of, let's say, node 2. So basically changing where it should go. So I'm going to go ahead and close this out. I'm going to run that beat server again. Once again, it's going to start sending out tasks. In a new terminal window, I'm going to just go ahead and use the standard worker process with that log level of info. We'll hit enter, and right off the bat, we should get all of those sensors coming through. So it's going to start doing that measuring process. But if I were to turn it off and close it off real quick, and then again, using a different queue in here, I can go ahead and put in a new task queue as Q1, being node 1. It's just going to sit there and wait. So if I were to open up yet another one and change the task queue to 2, this one should start working. And so let's go ahead and change this in here. Not sure what happened right there, but let's go. Oh yeah, we need to go into our source file, and there we go. So now we run it. This one should start getting all of those tasks, as well as ones that should have been ran already, right? That's because the actual beat server is sending something to Redis to make sure that those things are being run. Now, the important part here is that the first one, the first worker at node 1, is not running at all. It's just sitting there waiting, whereas node 2 is running constantly. And so this is actually going to be important for later when we actually deploy this to those different Raspberry Pis. Now, we can make these task queues a little bit more verbose than this. This is not exactly verbose. I wouldn't say it is because we're just kind of going off of general names here. Yes, you can design the queues to work this way, but I think it's a good idea to declare them. So the way we declare them is by doing Celery task queues in here, and we want to make it a list that we will then end up working with app.conf.taskqueues, and we're going to go ahead and set it equal to that right there. So now we need to know what task queues we're going to put in. The way we're going to do this is by using kombu, or kombucha shortened. We're going to go ahead and do from kombu. We're going to import queue and exchange. Now, this right here can get a lot more complicated than what we're going to do. So what I want to do with my task queues is I'm going to declare a queue here. This queue itself is going to be just node 1. Inside of here, we can use an exchange. Now, when it comes to Redis, we have to use the same name as the queue itself. If you were to use something other than Redis, you definitely can change the exchange name. This can, like I said, can get a lot more complicated. And I'll just keep the routing key in as node 1 as well. Once again, can get a lot more complicated. all I really want to do here is declare all of the queues I might end up using. So I can put ones that I'm not going to use yet in here as well. So basically just changing each one accordingly. So basically you would come in here and change it to node 1, node 1, and node 1, and then all the way through. So in other words, I want to go ahead and then say my nodes is going to be simply node 1 and then node 2. The reason for that then is now I can, instead of having it manually written in here, I can just go through for node and nodes. I can then basically do this same thing, but appending each one in there. So the Celery task queues.append, and then appending whatever the actual node name is throughout that process, just like that. And that will, of course, update things as necessary. Now, the same idea could be applied to the beat schedule itself. I'm not going to do it just yet, but now that we have these task queues in here, let's go ahead and rerun all of our different processes. So I'm going to go ahead and rerun my beat server, and then I'm going to go ahead and run my Celery worker process. So the first one, what I'm going to do is I'm just going to go ahead and say with no queue, and I'm going to do a log level of info, and we will see that there are other task queues available to us, node 1 and node 2. Let's go ahead and add in node 3, save that. We can then again refresh in here, and we can run this once again and see all of the different task queues we could possibly use. So now that I have all of these different task queues, the question really becomes, how do I know what options I have available to me in this beat schedule? Well, these options are the same options that are available to you in apply async on any given task. So if you were to go look into the documentation for Celery app task, this one right here, you can scroll down and you can see apply async, and all of the different arguments that are in here that are available, those same ones can be used inside of the beat schedule. So in other words, the task itself, if you do apply async, that is another way to call various things related to it. So you can call the keyword arguments, the arguments if there are any, and then any other arguments that you might want to have in here, which in our case would be the actual queue itself. So you would come in here and say queue equals to node 1. This is if you wanted to trigger them manually. We are doing it through the beat schedule itself, so we don't really need to know about that. But the fact that we implemented these options, it's important to know that they come from apply async itself. So the idea then is, now that we've got these task queues themselves, it actually makes sense to update our beat schedule based off of those task queues as well. And so that's also what we want to do. Very similar to these task queues, what we did here. I'm going to go ahead and cut this out for a moment. And we've got our beat schedule task queues for node and nodes. I'm going to go ahead and create a new one. So this is going to be our beat schedule task queue here, just like that. And so we set that equal in here. Now, naturally, what I already have is I'm iterating through the nodes 2 times. I might as well bring this up right here and then go ahead and set the actual configuration for it right below the task queue configuration. So now that we've got this of course starts to get a little bit more obvious as to what we need to do, which of course is passing in the node into the queue itself, and then giving it a different name, which in this case I'll just use some string substitution. So I'll give it my key here, and this is going to be equal to, the check temp dash whatever the node name is in here, and then we've got our key value pairs. So now the exact same task is going to happen across these different queues in here, and it's going to happen in the exact same way. You may or may not want to do this. You may want to write out a more advanced schedule, especially if your Raspberry Pi sensors are different and you actually need to have different arguments for them, in which case you can pass in args inside of the actual scheduler itself. Those arguments would then go into the same arguments that come into the shared task itself. We don't have any of those things right now. The actual temperature collection we have is just random, and then when we actually do configure it on the different Raspberry Pis, we're going to configure it the exact same way. In theory, we'll configure it the same way and make sure that it's working. The idea here is not so much of how that part's configured, how the actual physical sensors will end up working. It's much more about how we can separate how these tasks end up being executed themselves. So now going forward, the actual worker process itself will be designated to a specific queue. So if we did $Q, this is going to be node 1. We can still keep that log level of info. And once again, it will work, or at least it should work, assuming that I reset the scheduler or the beat worker itself. This now should actually trigger all of the different scheduled tasks for all of the different nodes. Notice that I don't have a worker process for all of those nodes. So naturally, I definitely want to have the same amount of nodes being defined in my settings as the ones that I actually have running or want to have running. So testing this stuff out all manually like I've been doing starts to get a little bit tricky. So what I want to do is, instead of running manual processes for each time I want to run the different worker process, I actually want to update Docker Compose to actually run different instances, run our Django server, the run server command, run our beat server to actually schedule everything, and then also run our worker process for each one of the nodes. Let's take a look at how we go about doing that now. Now we're going to bring our Django project into the Docker Compose environment that we already have set up. All that means is we're going to use our local Django code and bring it into our local Docker Compose up command, essentially. So the way this works is we're going to go ahead and declare a new service in here. This service is going to be simply web, and then we actually need to build out all of the things related to this. So that means I need to declare a build command or build argument here for the context of period, as in this local directory, and then a Docker file that we still need to get for Docker file itself. We will definitely grab this one from my blog, as we'll see in just a moment. Within this, we will also declare an environment in here, and I want to add in different environment variables I might want. So like, for example, our node ID. The default node ID we'll use is simply 0, just for the purposes of seeing how this will end up working. Next, we're going to go ahead and declare different ports in here. The ports that I want to expose is going to be 8088, and that's going to map to the local version of 8088, which means that I'm also going to declare this into my environment as well, which we'll see why in just a moment. But the idea here is this is going to be my Django container. This is not the Celery process at all. It's just the Django container. So how do we actually get the Docker file working? So to do this, we're going to go ahead and create a Docker file itself. Now, we could go into how to build out all of these Docker files, or you can just take a look at one that I'm going to give you. So you can either grab it from this Django Railway blog post. This is a production grade Docker file. Or of course, you can just grab it from the repo, because it will be there by the time you're watching this. So in this blog post here, I will have this linked in the project or the course description itself. But if you scroll down to the very bottom, you will see the Docker file. I'm going to go ahead and copy this and paste it in here. Now, normally, if you know Docker really well, you probably won't need to run through this. But for those of you who don't know it very well or at all, I'm going to go ahead and go through it really quickly right now. So first and foremost, we declare the Python version. This is going to be the runtime that is run in this Docker file. And this is, of course, different than the runtime for like Timescale or Redis. These ones will probably be some sort of Ubuntu distribution or some sort of Linux distribution as their default runtime, then run through all of the other installations. In other words, this is incredibly flexible for what we might need to run. In our case, we want Python 3.12, so we can just use that. Then we create a virtual environment, no surprise there. Then we do things related to the virtual environment, like upgrading pip, doing system level installations, like having a Postgres binding if we needed to use something other than what we currently have, which this one might be optional, but I do recommend having that in there. But these are OS level dependencies for our mini virtual machine, which we call a Docker container. Then we create a directory where our code is going to live. Then we change our working directory to where that code is. We copy our requirements file over to the container itself, which of course is this requirements here. We copy the SRC folder, which is this right here, into that same cold folder. We run the installation for all of that. We declare the project name. Hey, what do you know? CFE home. That's this right here. Of course, where settings.py is. That's the key part here. Then we create a actual script to run everything. This is a runtime script that we need to make executable. We remove things that we just don't need anymore. Then we run that executable runtime script. So the key here is we've got this GUnicorn project name, WSGI application, and it's binding to a specific run port, a specific port value, again, at runtime when we actually need it to run. That's the key thing here. It's a fairly straightforward process, but notice that I also have Python manage.py migrate. This is to make sure that our production database, our runtime database, is migrated and has everything up to date as need be. So that's all we really need to do in terms of context here. Now, every once in a while, whenever you see a Docker file, especially one that's building things locally, one of the things you're going to want to be aware of is you might need to bring in .docker ignore. This is actually important for big files like the virtual environment itself. If you just put venv here, it won't copy those files anymore. Like even if the Docker file says copy it, I think it ignores that altogether. That's important for if you had something like copy dot and then everything. But in our case, we have copy src, so it probably won't copy anything we don't want on there altogether. It's very similar to a git ignore for those of you who are interested in that. But now that we've got this, let's go ahead and update one thing inside of our project, and that's in CFE home and settings. In this allowed hosts here, I'm just going to go ahead and do star as in all hosts. This is just so that when I actually run this project in the Docker container, it ends up working, it runs correctly. So with this in mind, there is one other thing that we need to understand, and that is going to be our environment. But before I even get there, let's go ahead and I'm going to close out all of my terminals here and just open up a brand new one. This means that if I do docker compose ps, nothing should be running just yet. So now I'm going to go ahead and do docker compose up, and then I'll also add in --build. --build will only run when there is something like build in here. In other words, it's not going to build the container images for TimescaleDB because this is an external container. It's not going to build it for Redis either. Once again, external container. It's only going to build it for our particular code. Now, the downside to this current configuration is every time I change my Django code, I need to run that build command. In other words, I need to bring it down and then bring it back up. So at this point, what I see is it does attempt to run something, but I've got this Django secret key not found. In other words, my environment variables are incorrect. So what I can use, just like we've seen before, is I can use an env file for the more secret environment variables that we might want. Now you might be tempted to say, oh, can't I just use .env.web? And in theory, you would be right. env.web does have a lot of the things that we need. However, the database URL as well as the Redis URL, both of these things are assuming you are running this outside of a Docker Compose network. We are now going to be running it inside of that. So this no longer suffices. So we need to change it to something like container. So in that case, I'm going to go ahead and create that .env.web container. And we want this in the root of our project here. And I'm going to go ahead and copy the original web and paste in here. So now I've got my Django secret key and I've got these other values here, but the current configuration is now incorrect. So the really nice thing about Docker Compose is it makes a network by default. So all of these things can actually communicate with each other in the internal network outside of my local host. In other words, I actually don't need to expose these ports to my local host at all to be able to have access to them. So what that means is then our container image itself, we can use the default ports. So 54432 for the actual Postgres or TimescaleDB. And then for Redis, it is going to be the 6379. So those are the ports that I can use by default because, again, it's internal. It is this port right here and this port right here. This is export, that's the mapping for my local host. Inside of the network, I don't need to worry about that. One other thing I don't need to worry about is localhost itself. I need to use the actual service name instead. So in this case, it says Redis. If I change this to just simply Redis-DB, that is what I need to use in lieu of localhost. And for my database URL, I would need to use the TimescaleDB in lieu of localhost as well. So that's really the key here. The node ID, I'm going to go ahead and get rid of that one. I don't want that in there anymore. So now I've got my web container in here with a few environment variables that I am changing, and then that port container. So I'm going to go ahead and do Control-C on here, and then I'm going to run build once again. This time it's going to build everything. This time it actually can grab and connect into my Timescale project. In other words, it looks like I don't have any issues whatsoever with this first container image. So I'm going to go ahead and open up the local host at 8088. This one is working, so that's actually great. I can jump into the admin. All of these styles are gone. Now, the reason all of the styles are gone is because of how it's being ran. When I was doing it locally, I did python manage.py run server. But now that it's inside of the container itself, it is using the production level thing called GUnicorn, right? So the requirements in here, we've got GUnicorn. That is the reason all of those styles went away. In other words, this Docker file can be used to deploy your Django project into production. It can also be used for what we've got right here. So if you did just want to use run server, you could change this command right here, although I don't recommend it. I do recommend that you use GUnicorn in this case. So now that we've got that out of the way, the idea here is just to log in, and we'll go ahead and log in real quick. And there we go. So I logged in with the same credentials I had before, and now I should be able to see all of those same database metrics in here, and sure enough, I can. So of course, I now need to take this further and have all of the Celery instances working as well. So the way we're going to do that is by using inheritance inside of YAML, which we'll do in just a moment. But this, of course, is our web image. It has all of the things necessary to run the front end portion of our entire project here. But I do want to declare one more thing, and that is going to be our networks here. I'm going to go ahead and create a network called CFE so that I can just have specific networks that I'm working off of for each service that's in here. It's just something that's nice to declare when we actually start building out all of these various networks. Once we do that, we bring everything down, and then I'm going to go ahead and bring it all back up once it is fully ready to do so. And once that's done, I'm going to go ahead and run build once again, have that go. And then, of course, doesn't need to do a whole lot in here, but now we have everything inside of that specific network. So if we were to open up a new terminal window here, we can do Docker Compose and PS, and now we can see the different images that are running, including our local project here and the different service names that are available to us, which is fantastic. Okay, great. So do keep in mind that the local ports are still available to us as well. So that means that, of course, I can still run my Celery worker in here. So if I did Celery, let's go ahead and make sure that I'm inside of SRC here. If I do Celery and then -a, CFE home worker with the log level of info, I should still be able to access those original items. And sure enough, it is. And it's also catching up to a bunch of things that were left in the actual Redis database itself, which is actually really nice. So in other words, I can still develop locally and also inside of the containers themselves. But before I go much further, what I want to do is I want to update this so that when I do make changes to my Django code, the entire thing actually updates as well. In other words, adding watch into Docker Compose. Now we're going to further lean into using Docker Compose during development by using Docker Compose watch. If we were to make sure that all of our containers are down and then run the command of Docker Compose watch, we hit enter, what it's going to see is it's going to show us a couple of things related to Docker Compose, but then it shows me that none of the services were configured for watch. So we do need to configure them, and I'm going to go ahead and do Docker Compose down and then remove orphans to clean up my old stuff in there, just to make sure that's all up and running. You might need to do that from time to time as well. So in order for me to automatically trigger a rebuild when I make changes to the code, I come in here and I build a whole block called develop. And in here, I bring in a watch configuration. And so there's a lot of different things we can do in terms of watch. We can watch a bunch of different files that might change. So one of the things you might want to watch is maybe the Docker file, or maybe you want to watch the requirements file, in which case you can absolutely do that. In my case, I'm only going to watch the actual Django code itself. And to do this, I'm going to go ahead and declare the action. This is going to be sync plus restart. Sync would actually just change the code that's available. So if we didn't actually need to restart the server, sync would be great. We do need to restart the server, so I'm going to do sync plus restart. Then we're going to go ahead and declare the path we want to sync, which is going to be the src folder here. And then we want to declare the target itself, which is going to be code. I'll explain where those things come in just a moment, but the idea is now, when I have Docker Compose Watch going, it's going to go ahead and allow me to do all sorts of cool things. So if I do Docker Compose and Watch now, it will actually watch for changes inside of this src folder. So if I go into settings and just save the file, let's change debug to being false. I go ahead and save that file. It kicks off a restart of that container. So it's going to rebuild if it needs to and then restart the container itself. Now, what we want to see is where these things come from. The path src, I think, should be fairly straightforward what's going on there, but the actual target might not be as clear. That is actually coming from the Docker file itself. If we look into the Docker file, obviously there's all sorts of arguments that are coming in here. What we see is the copying the project code into the containers working directory. In other words, the local code to the target destination. That's what we're looking at here, just those two things. Once again, we could do the same thing for requirements, which would be this is the path, this is the target. So that's another thing that you could absolutely do if you wanted to. So let's go ahead and just see what that looks like by just copying and pasting this. The path is now /requirements.txt, and then the target is the temp itself, requirements.txt. Again, coming from the Docker file that I just gave you. That's it. That's how you can go about doing those different changes and making sure that it is syncing and running and doing all that. The reason that we have a restart in here has to do with GUnicorn. So if we scroll all the way down, we see GUnicorn in here, and this needs to be restarted when we make all of the changes to the code. If we were using something like Nginx with GUnicorn 2, you would still need to restart it because GUnicorn itself needs to flush out all of the new code. GUnicorn literally needs to be restarted. And that's it. That's now how we can actually watch the development mode for this. Now, the only downside of this is when I do save something, it takes about 10 seconds. It might take even longer than that if a bunch of things have changed, but overall, 10 seconds isn't too bad because if I needed to actually refresh everything in the first place, I would need to bring it all down and bring it back up anyway. So in other words, I'm going to go ahead and do this config, and I'm going to call this my Django debug, and I want to cast this as a Boolean value, and I'll give the default for now being true. In the long run, I'd probably want to change that to being false. But again, that's something that changed, so Docker Compose automatically changes things for me. This, I think, is really, really convenient when it comes to trying to develop with Docker Compose, because that's all we're using it for, is convenience to test out a bunch of different things and to make sure that, well, we can see how all of our nodes are being distributed across our actual project. Now, do keep in mind, when Docker Compose is running with our Django project can still be running here, and it's at 8088, and we can go into the admin, we can see all the stuff related to it. You can log in with the exact same project as we saw before, but we can still run it locally as well, and we can also run Celery locally as well too. That watch command didn't change that. But of course, I actually want Celery to run inside of the Docker Compose network as well. Now we're going to bring the Celery portion of our Django+Celery project into compose.yaml. The way we're going to do this is by using anchors and aliases. So this web right here, we can actually change it and call it an actual anchor. So the way we do that is right next to this declaration, we can use an ampersand and then do Django-base, something along those lines, and then we can re-reference this wherever we need to. So the way we re-reference it would be down in another definition, something like our node 1. So node 1 now is going to take in that reference, the exact same one. We're going to use these brackets here and then do star Django base. And that's it, not and Django base, just the star. And so node 1 is now the same exact thing as web, but now it's going to go ahead and change a few things about it. One of the things we want to change is the environment. This is, I'm going to give a node ID of, well, what do you think? Node ID of 1. That's not surprising at all. Next up, what I want to do is I actually want to change the command itself. So the command in here is going to be what we actually run in order for our Celery project to work correctly. And that, of course, is not going to be we don't have to do a list of commands here. We can actually just do a pipe and then do Celery and -a, CFE home worker. And this is going to be then our Q node -1. And then I can add in the log level if I wanted to. So node 1, and then we can repeat that again for node 2, changing the various IDs in here like that. So all from the Django base. Now we can also do the same thing with our beat server. So I'm going to go ahead and bring that in. This is a node of 0. We're going to change the server name to beat. And then of course it's just going to be our beat server itself. I cannot add a queue here. This is just for scheduling things. So I'm going to go ahead and run it just like that. So now we have 2 different nodes in here running, and they should all run with our beat server. Now, before I go any further, what I want to do is I actually want to bring everything down, and I want to delete the volume. The reason for that is so that I have, well, basically have fresh data coming through with Timescale and this new environment with everything coming all together. So we'll do Docker compose and we'll do down and then remove that volume as well. That of course is going to stop all of the containers that are currently running. We shouldn't have to remove any dangly containers or anything like that. But one of the things we might have to do is create a super user, which we of course don't have yet. So now I'm going to go ahead and do Docker compose and watch. This of course will build everything as necessary, and we get a port value, the problem with a port value on this current iteration. Now, of course, the reason for this has to do with the fact that, well, we've got our web container here and it's running on this port, but then that also is being inherited with all of my beat servers as well. So in this case, what I actually want to do is take this a little bit differently and go ahead and basically create a new version, which is going to be very similar to beat, but it's going to be for web, and specifically just go in right above our container here and just call this one now. This is going to be web, and then up here we're going to go ahead and call this our Django base, which is the same thing, but we want to go ahead and make sure that our env file is actually up there. And so this web base doesn't actually have a exposed port at all, but it is using all of the same configuration that we saw before, but it just kind of makes sure that the ports aren't being reused over and over and over again. They're just being reused on the web instance itself. So once again, we'll go ahead and try this again, and now it actually should work, and all of the instances should change when I make changes to the code. The instances that, of course, it's relevant to. So if I were to come into the, let's say, the Django debug and change this to being false, save it, that should restart all of those different containers as it needs to. It might take a little bit of time, but it does it automatically. This is so much faster than doing all of these things manually, as you might guess. So the next thing is I'll just keep it in as a default being true. So naturally, I need to create that super user. So how do we go about doing that? And so what we can do is Docker compose, execute, and then we grab the service name. So in our case, it's just going to be the web service. And then we can actually do bin/bash. This brings me into the interactive terminal. It's similar to like SSHing into a virtual machine. I can list things out. Hey, what do you know? Here's all of my Django code with a new item in here. If I do cat and take a look at that new item, I can see this is actually the commands that are running through. The Docker file actually created all of this stuff, and it allows it to run with Unicorn. So that's actually the thing that's running. But being inside of this container, I could actually run python manage.py, create super user, and then I can actually go through this process on how I might want to create a super user, once again using CFE. Once I do that, I should be able to log in again to my local host version of this particular web instance, which of course is at port 8088. And so if I go in here and log in, I should be able to log in. You could always save the password if you want, but notice that none of my metrics have changed, but now they're actually all running. And so we see the node ID in here and it's actually running correctly. So what if we actually wanted to add yet another node in here? Well, one thing I want to check is that my Celery settings is ready for another node. Sure enough, it is. It has node 3 on here. So I already have a queue ready for node 3. My compose.yaml just simply didn't have node 3. So let's go ahead and add it in. I'm going to go ahead and copy this node 2, create it as node 3, node ID at node 3, and do all of the queue stuff at node 3, save it. I'm going to go ahead and exit out of the Docker container instance itself. At this point, I actually do need to restart everything because it's not actually checking compose.yaml. So I'm going to go ahead and restart everything with that watch, which won't be a whole lot different here now. And so I've got everything in here. Notice that node 3 is listed out. If I do Docker Compose, let's go ahead and clear this out with Docker Compose and PS, I can see all of the instances that are running here. We've got our Beat server, we've got our Django server, we've got node 1, 2, 3, and so on, Redis and Timescale, as well as our base server. Our Django base is in there, as well as web. But of course, Django base doesn't really do anything at this point. We could make it do something, but it's just not necessary because none of the Celery processes need a port that my local machine can access. The only port I need really is the Django port in here. And so now we're going to start seeing 3 being trickled in. Notice that there was a ton of 3 happening all at one time. Now the reason for that has to do with the fact that my settings had it already set up. So node 3 has been in here for the long time. So the Beat scheduler was already running all of those tasks. It was already telling the worker about those tasks, even though the worker was simply not available. So in other words, if one of the workers goes down, the Beat server is still going to be sending tasks to it, even if it goes down, which is actually really nice. Now, there's a way to clear those things out so they don't persist, but the idea here is the actual system, the entire system is now working. It's now distributed, and it's all running through Docker Compose with our Django project with Celery, and then of course with our TimescaleDB instance that's running in there along with Redis. So it's actually really, really cool. And of course we can build out everything that we might want with this entire environment. Now I probably don't need all of these nodes. And one of the things I could probably think about is the configuration itself. Maybe I change it to where these nodes right here are based off of environment variables as well, like the number of nodes that I want to have. That might be a good idea so that when I spin it up, I don't actually have to hard code things ever. But that's not really the point here. The point here is so that we have this sort of working model so that then we can start distributing this in another place. So it's not just through Docker Compose, but it actually uses proper devices. But what we have here is really the foundation for being able to do that. Now we're going to do a fresh installation of Raspberry Pi OS Lite. Now the reason it's light is because it won't have the desktop. It's going to be a headless environment. So the way we actually interact with that Raspberry Pi is through SSH. Now we're going to be doing this on our local network, which means we need to set a host name, a unique one for each Raspberry Pi on our network so that it's really easy to SSH into those machines without learning the IP address up front. Because actually trying to get the IP address going and stuff like that, that actually takes a number of steps, which of course makes it is possible to do that, but just using a host name makes it a lot easier and a lot more flexible because all of us will have different IP addresses that are assigned to our Pis, but we will most likely have the exact same host names. So that's what we're going to do right now. So if you don't already have it, download the Raspberry Pi OS installer so you can download it for all of the different systems in here, and it's going to look something like that. Once you have it, you're going to open up the Raspberry Pi imager. So what's happening here is we are going to change the Raspberry Pi device based on the device you actually have. Now, I think as far as Wi-Fi is concerned, Raspberry Pi 4 and above will have Wi-Fi. So Pi 4, Pi 5, and so on has Wi-Fi right installed. Pi 3, I don't think it does have it. So the reason I mentioned Wi-Fi is because I'm going to configure Wi-Fi for these devices. You can hook them up directly to your network as well, but I'm going to be using Wi-Fi. That helps simplify some of the process as well, as we'll see in just a moment. So select the device that you're going to be running on, then go to the operating system. Do not grab the desktop one. I know it's recommended from them, but that's if you want a desktop version of it. We don't want that, so we want to have the light version, which is actually significantly smaller of a version than the actual desktop version. So in this case, we've got Raspberry Pi OS Lite 64-bit, and then I'm going to go ahead and choose my storage. Right now, all I have is an external hard drive on here. That's not what I want. I want to actually implement or insert my micro SD card. This micro SD card has already actually been flashed with a previous version. So whatever you choose here, it's going to erase everything on there, as it will warn you, of course. So now I can select that storage. It's quite a bit smaller. 64 gigs is not too bad. I'm going to go ahead and hit next. This is where the key part for all of our systems need to be set up. We're going to go in, edit settings. So I already have a bunch of settings that are here and saved from previous iterations, from previous Raspberry Pis that I already set up. And so those previous Raspberry Pis actually stopped at 3. So this one is going to be 4. Now I'm going to go ahead and test this assumption out on my local network by actually going in and doing SSH CFE at django-pi-4.local and hit enter. And if I can access that, that means, of course, it's taken. This is timing out, so I'm going to go ahead and try 3. This one I should be able to access. Great. So that's definitely the last one that I did. Of course, if you're doing this in the first place, you probably don't need to do that check, right? So you would probably use just simply Raspberry Pi. I'm going to go with the naming convention of Raspberry Pi, then Raspberry Pi 2, then 3, then 4, and so on. So in this case, it's going to be 4. I have my wireless network all set up already. I selected my actual country. Of course, I'm in the US. I did my time zone, which I'm really close to Denver. And then I'm going to go ahead and use the keyboard layout of US. Those are things that need to happen. You definitely need a username and password. If you do not have a username and password here, it will not connect. I recommend using CFE as your user because of what we are going to be doing with Ansible in the next part. So let's keep that the same as well. So once again, the naming pattern for the very first one is just simply Django Pi. That's it. The second one is going to be Django Pi 2, third one 3, and so on. Now I'm going to show you my inventory file just so you can see exactly what it is that I'm going to be doing with Ansible in the short run. Okay, so the next thing is our services. You also want to enable SSH. So you want to use the public key for this. So this public key is available on your system as well. So if you actually go in to your system and do cat_.sh and then id rsa.pub, what you will see is something like this. Now, of course, if you don't already have this, all that means is you need to generate an SSH key with SSH keygen, do RSA, and then just like that, this will create your private key pair. And if you use the default, it will go in the same location as this. So the idea is once you actually have that key, you will copy this value and you're going to bring it over into the imager and you would paste it right in here. That's it. That's all you need to do in terms of passwordless authentication. Passwordless authentication makes it really, really effective for using Ansible. Ansible is going to do all of the installation of our Django project, as well as spin up a Redis server and a few other things in there as well, including connecting into our cloud-based TimescaleDB soon. The next thing is the options. You probably don't necessarily need those things, but I will have them. So that's going to be my customization. I'm going to go ahead and say yes, and I'm going to let it run. So do keep in mind that you are going to have to confirm this with a password as well. Once you actually confirm the password, it's going to start this writing process, and it's going to go ahead and build out your image. This actual micro SD card, you will then take and plug into your Raspberry Pi, connect it into your power, and then it will automatically configure everything and attempt to connect to your Wi-Fi. Now, of course, if you did the incorrect settings with Wi-Fi, you're going to have to go back and reconfigure it. I've had to do that a few times just to make sure that everything is working correctly. So that's definitely a setting you're going to want to make sure that you have. Now, how you know it's not connected, one of the ways you would know is by simply trying to SSH into it, right? SSH based off of the host name you gave it, then .local, so it's using your local network, and then your username and all that. If this pins, if it hangs for a long time, then of course, yeah, it's not actually working correctly. And so, of course, that is something you'll need to diagnose. There's a lot of things that can happen in this step that might cause a lot of frustration and a lot of errors. So do be patient with it and try your best. Of course, if this part's not working and you're really just struggling with getting the Raspberry Pi of it all, so much of what we'll be doing after we configure Raspberry Pi will be able to be done with what we did in the actual Docker Compose and all of that. So let's go ahead and let this finish, and then I'll start the process with Ansible. My Raspberry Pi was finished. I'm going to go ahead and just SSH into it now to see that it is working. So SSH CFE at django-pi-4.local, hit enter, and I get this. This, of course, is making sure that we want to actually connect to this host, because if this host name changes or anything like that, if you were to repeat this process, this part would actually fail, which you would have to remove it from your known hosts on your local machine. But in this case, it's brand new, so I'm going to go ahead and say yes, and I'll see that it is added to my list of known hosts. Once again, if you pulled it out right now and then re-imaged it, this would fail. You would not be able to SSH in, which you would have to update your known hosts right then and there. So what we've got here is now a Linux or an actual Linux machine, not a virtual machine anymore. It's actually metal hardware. It's real hardware. You can actually use it. It's this Raspberry Pi right here. They can install all of the things you need to install, including all of your local Django code. Now, the challenge here is actually getting all of these things configured, right? Because there's nothing on here other than what's necessary for the operating system itself. So naturally, what you could do is you could do everything manually. You could do something like Python 3. Let's see the version here. This is 3.11, which is probably fine. We could absolutely upgrade this version if we wanted to. I don't think it's necessary at this time. So what I can probably do is Python 3-m venv venv. And what this hopefully will show us is it creates our virtual environment, and we could go through the entire process there. Now, if you're wondering, why isn't this incredibly fast? Well, the Raspberry Pi performance is going to vary based on the actual Pi that you have and also the systems that you're trying to use. So in this case, I'll go ahead and do source venv bin/activate, and then I'll go ahead and do my pip install Django, and then I could go through all of that same process that we had before when it came to configuring our local project. This right here is incredibly tedious, and it's not something I recommend for most people to do. So instead, what I recommend that you do is you use Ansible. Now, this tedious process might be a rite of passage, doing it manually from your local machine into your Raspberry Pi. I actually would recommend that if you have no idea how to bring code onto it. That is definitely a useful process. But using Ansible can help shortcut so much of this. So in my case, I actually created all of the playbooks necessary, all of the roles necessary, so you can just have this work, just like our Docker file. So in order for you to be able to get those things, you're going to have to go onto GitHub and clone it, which we'll see in just a moment. But the key thing here is inside of the Ansible folder that you have that you need to create an inventory.ini file. So in my case, I have my main node here. This one is actually a Raspberry Pi 5. It is definitely my most robust Raspberry Pi there is, which is why it's going to host my Django project and my Redis server and a worker server itself, or a Celery worker, and also a Celery beat. So my main node is going to do all of those things. Once again, this could probably be improved in the long run, but the beat server doesn't actually take up that much bandwidth. The Django project is not going to get that much traffic going into it. The worker process is going to be the one that actually uses the most stuff, in which case I could definitely bring in some sensors and stuff like that and hook it up directly to that one. All of these other nodes, every single one of them is just a worker node. That's all it will end up doing, and that's what all will end up building. So after you do all of the installation and you can actually access each one of the nodes themselves using SSH, then you're going to create this inventory.ini file in the same format with node 1 in there, node 2, and so on. And of course, if you know the IP addresses, you could use that as well. But since I don't want to actually find out the IP addresses, I just want that to be as automated as possible. I'm going to work off of this right here. And so the code itself, this is where it's going to come in. So at this point, you could go through the process of getting all of this code on your local machine. So what I want to do is I want to make sure that it is actually pushed. So let's go ahead and check that. It is pushed. I'm going to refresh all my code on the repo itself. And what you'll see is this getting started with Ansible, Raspberry Pis, Django, and Timescale. So what we've done for this so far is this part right here. So the very first part of getting all of it set up, that's what we're working off of. Now, if you want the Ansible code locally, you're probably going to have to clone it or download the folder itself. So you could always go to code and then download the zip folder and then just bring over the Ansible folder itself. That folder has everything you'll need to make sure that Ansible can run with this configuration, with the actual Django Pis like this. We've got a main import here that's going to deploy our Django project and all of the playbooks for it. So I'm going to break those things down in a moment, but the idea here is you want to be able to bring this over because then you're going to work through all of these processes. Now you won't need to create a virtual environment because we already have one. We will need to do a few installations for it, but then we're going to go ahead and create a production.env file that we will use for a production database for our production-based timescale instance, as we'll see as well. So we'll definitely set that up too. But of course, before we get to all of that, we want to go ahead and make sure that we can use Ansible for encryption and stuff like that too. So that's a big part of it. Next up, once it's all done, once all the configuration is fully done, then we will finally run our Ansible Connect hosts. Then we'll go ahead and deploy it, and then we will go ahead and restart some of the services. What you will end up with is something like this. So notice I'm on Django Pi local, and I can actually go into the Django admin. The styles are there. I'll talk about that too. And then I can see all of the different nodes in here. There should be 3 of them at this point because I haven't added the 4th one just yet. We will see that very, very soon. And it looks like everything went down, probably from my test. But the idea being that each one of these nodes is going to be actually allowing us to collect more and more data. And it's going to start getting a lot of data in a short amount of time. So all of my tests to get to this point really just were, I don't know, an hour or so of data that's being collected. Granted, it's still the random data. So you could obviously have those sensors in there. And once we actually do the Ansible stuff, all of that will be configured for you to be able to start adding sensors into each node. So without further ado, let's actually go through the Ansible part now. In the last few parts, we configured some things about our Raspberry Pi. Now, what we're going to do is actually configure a cluster of Raspberry Pis. Doing this is not for the faint of heart, and it actually takes about 30 minutes of me speed running through how to do it with Ansible. Now, this could be a whole course in of itself, just using Ansible to deploy Django onto a cluster of virtual machines or bare metal hardware, in our case, a Raspberry Pi. So definitely consider that before you do this part. Now, if you were to jump through this part, that's okay. We will be going back to Docker Compose to start using production databases or production timescale instead of the one we've been using. That production database will also be used on these Raspberry Pis, but it's only going to be in a very simple manner. So what you'll end up with is 4 Raspberry Pis, assuming you have 4, working in a cluster, running a Redis server, and connected into a production TimescaleDB using everything that we've done so far. But again, this takes a little bit of time to explain everything that's going on in order for it to work. It's definitely not as simple as Docker and Docker Compose, but it is almost as reliable. So let's go ahead and take a look at how to do this. Again, if you want to skip it, feel free to go to the next part where we go back into Docker and Docker Compose. Now I want to walk through the different playbooks that are going to occur in Ansible itself. So we've got a few different ones in here. Connect hosts. This one really just calls the connect host role, as we'll see in just a moment. This needs to be run only when you add new hosts or new Pis to your entire ecosystem. What this will do is if we look into the roles of our Ansible project, we've got this connect host here. There's only a few tasks. What it does is it actually gets all of the host IP addresses and then it updates each host to make sure that they all have access to communicate to one another. This is actually really important, as we'll see in just a moment. Now, if you aren't familiar with Ansible, no worries. You don't actually have to know exactly what's going in here, other than the fact that when things are declared, they happen in order. So this one's going to happen first, then this one, and so on. And over time, you might come to learn how to use all of the Ansible things. So this connect host playbook here really just calls the role. Roles can be reused, as we'll see in deploy Django. So if we look in deploy Django, this project here, what we've got is our deploy Django project. This is going to go to all hosts, right? So just like connect hosts went to all hosts, this deploy Django project also goes to all hosts. Now, at this time, if you already had your own version of what we've been doing with the Django IoT project, you can change your GitHub repo to that repo, whatever that might end up being. I don't recommend doing it yet. I do recommend sticking with my repo because I know it works for sure. But if you are super interested and ready to go for it, change your repo right now. So what we see here is we've got clone repo, which is coming based off of this itself. Then we've got services configuration. And then I also have a task to install the Redis CLI. This is really just to make sure that I can connect to Redis and do just a quick little Redis ping and then get Redis pong back. Next up, we've got deploy Redis. Notice it's only on the main host, and we've got Redis right here. Now, going back into the inventory file, this is where the naming thing makes a big difference. This one is main. This is the main host right here. These are the nodes. These are all of the other hosts in here. And then we have variables for everything, which is just saying the Ansible user is CFE. In other words, SSH CFE at, my host, whatever it might be. So Django-Pi-1.local or so on. So this CFE user is really critical for that because it's used in many other places. Now, Ansible is really flexible and you could change it to where you could use your own user, but you want to stick with me on this one just because I didn't make all of the possible variables that you could with Ansible to keep it as concise as one could possibly without, breaking your mind maybe. Nevertheless, what we've got here is let's go through this process of deploy Django, the clone repo role. So what that means is we go into clone repo right here. We look for tasks. These are all of the things that are going to happen in order before services config. We're going to go and take a look at main here. What we've got is, first off, the OS level dependencies. All of these things are going to be installed. Hey, what do you know? This is actually just like Docker. We had a lot of these same dependencies in Docker. That, of course, is on purpose, and especially in that order. So we definitely want to have those dependencies in there. If you have other OS level dependencies you might need, feel free to add them in here as well. So what's nice about Ansible itself is it can use app by itself and then update things and make sure that these are all in there. You can also uninstall them using the same sort of configuration and just by changing the state. Next, what we want to do is decide where we're going to deploy our application, where we're going to bring in our application code. In this case, we're going to bring it into OPT app. That's where we're going to do it. Slightly different than what we did in Docker, but still the same idea. We need a destination for our code, so we want to make sure that that directory exists. And we can also check the playbook directory itself, as in this directory. The reason we check that has to do with other pieces in our project, which I'll talk about some more later. But the idea is knowing where the playbook directory is so you can reference it if you need to. Next up is cloning the public repository. Here's that GitHub repo. So going back into our playbook that we had, we can change the variable right here, which will affect the roles. We can also change the variable right in the roles because these are the default values that are going to be used in there. There's another one that's called defaults that can be basically the same thing inside of the role itself. We can ignore that for now, but the idea is you can declare the repo right here. You can even put it in here if you want. It doesn't have to be a variable if you don't want to. Next up is going to be the actual branch that we're using. In our case, it's going to be the main branch. It shows us the destination is the same destination that we're using up there. Then we also want to force this. So GitHub is going to be our place of truth. Whatever's on our nodes doesn't really matter. The code that's on there we can think of as ephemeral and it doesn't matter at all. So we want to force those changes when they come through. Now, there are some caveats to when this might be necessary or not, but in this case, we want to make sure that that's happening so the code on our repo is actually syncing those things. Now, notice these things become user. This is like, hey, super user, make sure you make this happen, and we're going to be using that user that I provisioned with, which is that Ansible user, which of course is declared right here. So CFE is that user. That's the actual variable that is declared right in the inventory file. And then this registers the result, whether or not it works. Next up, what we do is we copy an encrypted .env file. This is actually really cool and very straightforward, as I'll show you in just a moment. But the idea is it's going to copy a file from my local playbook directory. This is showing me my local playbook directory, then the relative path to that. So this is going to help me find where these things are. So this is going up a level, and then so on, and then eventually getting env.prod, which right now I actually do have one, but it's basically going to look for this location right here. That is why we actually debug that playbook directory. Then we actually output it as a .env file, just .env, to the root of our app directory. Now, the key thing here is this is not the src directory. There will be an src directory from this destination right here. So we will see opt app and src, and that's where all of our Django code is going to live. So when we clone it, it's going to have all of the things from the repo itself. That is, if we look at the repo, it will have all of this files just like this. It will be organized exactly like this as well. So that means src is going to be in there. So the Python decouple should automatically be able to find this .env in there. Next up, we set the node ID in this env file, which is done through Ansible. It's really nice. It has this regular expression where it's going to look for that, and then it's going to look for the node ID value. Otherwise, it's going to go ahead and set 0. Where does that node ID come from? Well, going back into the inventory file, we've got 1, 2, 3, and then 4. 4 is not in there yet, but it will be soon. So this will set it in that environment variable file so that our Django project knows which node it is, and it can use it directly. We can also debug the clone results. This probably should be up higher when it actually does the cloning if for some reason it fails. Next up, we want to make sure that our virtual environment is actually there, and I do this on OPT venv. So not inside of the app, but rather in its own folder called venv. This is very, very common to have one virtual environment for one Python project on a machine like this. Whether it's a virtual machine or a Raspberry Pi, this is very, very common. Every once in a while, you might need to have multiple virtual environments. In this case, you don't need to. It's not necessary. So that's where I put it. In this case also then, what I come back to after I create that virtual environment, which is exactly what this next step will do, we install the project requirements in here. And then we are going to go ahead and run our virtual environment command and then do our requirements that are coming directly from our app, which should already be in there from the clone. Then we run our migrations only on the main host. Shouldn't have to be done on all of them, just on the main host itself. Then we run collect static. So the key thing here is with these migrations, the env file needs to be correct. This absolutely needs to be the correct one. Otherwise, the migrations might not necessarily work for all of the machines, which is important. So if for some reason they're not working, just comment this out and then it will migrate on every single host itself. So what we see here is this win command will say, hey, the inventory host name for this current iteration, look to see if it's in groups main, as in, is it in this one? If it's not, then skip this part, and that's true with collect static as well. Great. So that's deploy Django. That's the first part. That's cloning the repo itself. It's going to clone the repo and do all the installations necessary. After that, we do something called services config. Now, what this is going to do is to make sure that we have system services that are going to run. What are those system services? Well, if we go into the role itself and go into main.yaml and scroll to the very top, the first one we see is the gunicorn service. Once again, we see that it's only in that main group because only that main group needs Django to run with gunicorn. The next one is Celery Beat. Once again, the Beat server only needs to run in that main group, only on one host. That's it. We only need both of those on one host. Now, Django itself could be distributed on multiple hosts, and then we could use something like Nginx to work with multiple hosts, which I'll talk about in a second. But the idea here is we've got our Celery Beat server and our Django gunicorn project running on that host file. Now, I'll look at these template files in just a moment so we can talk about them. But after that, we create a Celery worker system on all hosts. We put this everywhere, right? Because I do want my main host to do it. Of course, I could always just make them for my nodes here. If I wanted to make them for my nodes, I would just copy this, bring it down here, and just say nodes. Just change the group itself on when we want to create that Celery worker process, if it's available in there whatsoever. Next up, we're going to go ahead and reload systemd. We just want to make sure that after we bring in all of these new services, we are going to go ahead and start them after that. So Nginx is another one that we're going to go ahead and configure and make sure that that's all working as well. Nginx is going to be how our gunicorn and our Django project is accessible from the local network. Our local network will be able to use it. And then we'll enable Celery Beat and make sure all that's working, and our Celery worker. Great. So all of these processes are using systemd. We'll look at that in just a moment. But the idea here is each one of them has its own template. So if we scroll back up to the Beat service, we see that there's this template here, celerybeat.service.j2. This template right here is coming in this folder, and we see all of these different templates here. So if we look at Celery Beat, the very first one, we can see what's happening. So if I break this down a little bit, I see the working directory. Hey, what do you know? SRC. That is where my code should absolutely live. Then to execute this, we use the virtual environment bin and then specifically Celery in there. We don't need to activate the virtual environment and then run it. We can just run commands directly without activating it. Then, of course, we use CFE home. That is the app name inside of the SRC folder. No big surprise there. Then we just run beat and then we add info. Now, we can expand on this and put logs and all sorts of stuff for this service. I just want to keep it nice and condensed as to how it's going to end up working, and that's it. So once again, my CFE user is going to be responsible for this service. This is another area that could definitely be improved in the long run, but for now, that's just fine. Next, the Celery worker is not a whole lot different. The big part that is different is this node ID here, the actual, queue that we're going to end up using for each individual node. That's also, of course, important in this case. And so what we've got here is this node ID. Once again, that node ID is coming from the inventory file. I don't have to declare it anywhere else. It will automatically be used right in this queue. And so that will allow us to actually have additional inventory items in there. Great. So that's the Celery services. Then in gUnicorn, we have gUnicorn being bound to the local host at port 8080. This actual definition is important, but once again, it's not a whole lot different than what we saw within our Docker file. I have workers at 3. You can lower this number to 1 or 2 or 3. It really depends on how many CPUs you have on your system, which I think in this case it's 3 will be fine. I think it's whatever the double the number is, you need to have at least that many cores on your system, which I think I do. I would have to actually check that off the top of my head. I don't actually remember exactly what this is, but I think workers, which should work just like that. This I referenced on some other code, which is why it is there. But the idea here is we can run gUnicorn at this port, and it's going to run all of the time on that one single host, which also has Nginx running. So this is the Nginx configuration to make sure it can actually, forward our ports to this actual host itself. So the idea is Nginx is going to listen at port 80 inside of that same exact machine, the same virtual machine. That is the django-pi.local machine. There is gUnicorn running at port 8080, like we just saw in that configuration. So port 8080 is right here. Nginx will forward the request as a reverse proxy to that port. And so what we've got here is that exact forward processing. We listen at 2 different values here, 2 different versions of the IP addresses. So what we've got is the default server is coming through. It's going to listen at port 80. Then it's going to forward that request to port 8080. And then we actually have our server name. So if we did actually want to have multiple instances of Django, we could come in here and do that. We would have to change the IP address to something like Django-pi-server 3, which of course I don't actually have. And that would be how you could actually forward it to other servers as a load balancer. We don't need to do that. We're not going to have that much load on this system whatsoever. Even if we had hundreds of employees checking this all the time, it would probably handle it just fine. Maybe even thousands or tens of thousands, realistically, with how powerful this Raspberry Pi is. So next up, we've got the location. This, of course, is doing that proxy stuff. It's forwarding the request. And then we also have the static files. This part is actually key and something I did change off the video for our Django project so they can actually load our static files itself. We'll come back to that as well. So that actually handles all of these templates. Each template goes to systemd directly as its own service name, basically. And so if we scroll through all of them, we got the gUnicorn service, the Celery Beat service, and so on. And then finally, the Nginx service will only go on, gUnicorn will only start on the actual inventory group. Nginx will only install on the actual inventory main group, and so on. Right? And so that starts, and then we set that Django project as our default, and that will run as well. And then it'll restart Nginx when things change there. Great. So a lot of stuff, a lot of things going on in that deploy. As far as if you had to do this manually, it would be a very tedious process. Now, that's all of the Django project stuff in general. The Redis itself is actually very simple, and it only goes onto the main host as well. This, what it will do, is it will install a Redis server. This is probably something we would want to change in the long run to a production one. The reason I'm doing this is so that it's really easy and straightforward to get it going. I'll talk about the production one later, but then you've got all of this configuration here. The key things for this configuration in this case are where it's bound, so it's at 0000, and then whether or not it's protected mode. You could always change the port, but do notice that the port is 6379. So we'll actually take a look at that as well. Okay, so now what we can do is we actually need to update our code a little bit to be ready for this new node. So going back into Celery, I only have 3 nodes in here, so I need to add in node 4. This is so that node 4 actually is in the task queues themselves. So I'm going to go ahead and save this, and I'm going to save everything. So I'll go ahead and do git status, and we'll go ahead and do git --all, git commit, and then, Ansible demo for node 4. Something like that, and then we'll go ahead and push it. Now, if we were to go through all of that Ansible, if I were to write the code and just go step by step on how all of that works in more detail, this would be a whole course in of itself. Even this section is a little bit long, but I wanted to make sure that you had all of those things done correctly. So the idea here is now the current iteration of the code. If I go into SRC, if I go into CFE Home, into Celery, I should see all 4 nodes in here. Now, we can continue to add nodes to it, but the thing is, if we continue to add nodes that don't actually consume this data, the B server will continue to send them tasks until they consume that data, unless we flush it out, which is not something I'm going to set up at this time. But the idea is now we've got all of those values in here, we can finally run our Ansible playbook. Now, there's a couple different ways on how we can go about doing this. First off, we want to do pip install-r requirements.dev.txt. And what that will do is install Ansible as well as Rav. Now, Rav is just a convenience method that I created specifically to just remember the different commands that I might want to have. So like Ansible Vault, encrypting, decrypting, running our Ansible, playbooks and all of the different configuration, connecting our hosts, and doing our Pi services. So all of these things are just referenced in there for your use. If you want to use them, you just go into the root of your Django project and do rav run, whatever the name of the script is. In this case, let's go ahead and do encrypt prod env. So this will do that encryption process. I'm going to cancel it out for right now, but of course, feel free to use rav if you want to. I'm actually not going to use rav at this point for this video, but I will show you the Ansible stuff altogether. So now what we have is we are ready to start doing the actual production, env.prod stuff. And so here is an example of what env.prod would end up looking like. Mine is currently encrypted. So what I want to do is actually decrypt this. So the way we decrypt this is by using, first off, we need to be in the same location as that file. So if we list out everything, we can see that env.prod is right there. So to decrypt this, we use Ansible-vault and then decrypt, and then the file we want to decrypt, which is env.prod. We hit enter, and it's going to ask us for this password. So I actually created this password before, which I will redo in just a moment. But now that it's decrypted, I can see the values that are going to be injected on my various hosts using Ansible. So it will be decrypted using Ansible on the host itself, which is super nice. But the idea here is we have a production grade database URL, which we still need to set up. We also have this Celery broker Redis URL. So this right here has the actual Redis URL we're going to be using that Ansible will configure for us. So notice that it's on django-pi.local 6379/0. That's important. We need to make sure that that is the correct Redis broker because that's going to be our main host and where we're going to go ahead and install Redis. So before I actually do the installation process or even configure our production database, I just want to show you how to encrypt this. So it's really cool. It's really simple. Let's go Ansible-vault, and then we do encrypt, and then the file we want to encrypt, which is .env.prod. We hit enter. It's going to ask us for a password for this encryption. Now, the password you use isn't really that important. Obviously, you probably want to have a good one, but the idea is as soon as you encrypt it, there it is. So this is actually really hard to decrypt without that password. So what we end up doing is when we run Ansible, I have this ask a vault pass on here by default. So every time I run Ansible, it's going to ask for that same exact password. So when you go to encrypt other files, if you need to, you want to make sure it's using that same password or you know it. I think using the same password is probably a good idea. There's also a file that you could create with it. Definitely check the Ansible docs for that if you are interested. So the first thing that I need to run is connect hosts. The reason for this is because I just added a new one. So what I want to do is I'm going to navigate into the Ansible folder, just like that. Then I'm going to go ahead and grab the relative path for this, which is going to be a little bit different than what I will show here. So let me just open up a new file. This is the relative path. So to call this, we're going to do Ansible playbook and then that connect hosts here. Now, the reason I actually don't need anything else has to do with ansible.config. It's automatically going to look for the inventory file. It's automatically going to use CFE as our remote user. And then it's got a few other connections that it's checking. And it's also looking for roles in this folder right here. Cool. So with that in mind, I'm going to go ahead and now run our command that I just wrote out, which is this one right here. And we will go ahead and connect our hosts. Here it is asking for our vault password. I'm going to go ahead and run it. Now, this assumes that the actual env file is actually encrypted. And so once again, if we wanted to see that file, we just go into clone repo and we can see that it is encrypted. So let's go ahead and look for it. There it is right here. Notice that it actually is just going to copy, but I have this command of decrypt in here. So if I didn't have that command of decrypt, it wouldn't automatically do it. You want to make sure that you have that command. But now what's going through here is it's going through all of the hosts that I have available. In my case, I have 4 different hosts available, my main one, and then 3 worker nodes. It's going through all of them, and it's updating all of them in line. It's happening really quickly, and all of this comes out of the gates with this one single task. Now, and there's also dependencies that the Raspberry Pi OS already has installed too, to make sure that all of this is working, like the Avi daemon, that right there, or Avahi, I don't know what it's called. But the point is, we can now actually have all of those hosts connected. So the next step is actually to deploy Django on all of those hosts. So this is going to be now deploy Django, and I'll go ahead and run this now. This should clone my current repository. So I did change it, right? I made a change to it, and it will absolutely install the new one. The key to all of this, prior to having our production database, which you don't have yet, we will do that in a moment. But the idea is, the key to all of this is I want to make sure that my Django local Django administration has things beyond 1, 2, 3. It actually has a 4th value. Value 4 should come once all of this is done. I'm going to let all of this finish, and then I'll be right back. My deployment process succeeded, and it changed a bunch of things on one single instance and a few things on other ones. So this is actually really cool that it sees this. Now, the chances that this all works perfectly for you the first time are unlikely. So if you were to just run it several more times, you might actually solve a lot of issues with that. And of course, each individual task might have its own problems, and like cloning the repo and stuff like that also might have its own problems too. But overall, the idea here is if I scroll through, I should see all of these different changes. I should see all of the tasks being run in a orderly manner that actually does work, hopefully correctly, right? And so here's that debug playbook. It shows me where those playbooks are on my local machine. Really nice, so that I can know that the copying the env file is correct, setting that node ID also correct, and all that. So I want to make sure that all of this is done, and I'm going to do it on a repeated basis as well. Now, one of the other things is to make sure that Redis is installed. Notice that when it says OK and it's just green, that means that nothing changed about it. So it's already ready, it's already running, it's already doing everything that it needs to. So if I were to jump into my Django project right now, more than likely I won't actually see the node bringing things in just yet. There's a possibility that I will, but there's also a possibility that I won't. So I'm going to go ahead and take a look in here just to see. So no, I don't actually have any of the node ID of 4 running just yet. Now, the reason for this is because I actually need to restart the services, which I'll do in just a moment. But what happens is, all I did here was deploy all of the code. If all of my services were already running, in my case they were. In your case, they probably weren't. But if they were already running and I added a new node, that means that, well, it's already running. It didn't actually change anything. So this actually really comes down to GUnicorn itself. So if we look at our services configuration here, into our templates, into GUnicorn, this right here is using the old code still. It didn't actually change any of the old code. So one of the things that you could consider doing is combining how we actually run our services and then adding different handlers in there. This is something that I didn't optimize specifically so we could talk about it. And if you want to learn more about Ansible, that is where you would go. So really what I need to do is just run this restart services, which will quite literally restart all of the different services that I have on my project. So I'm going to go ahead and copy that and save that. So if we take a look at our restart services here, the role itself we can take a look at. So services restart in main. All it's going to do is look for systemd, make sure that we reload what's in there. We restart GUnicorn, which will refresh all of the code that's running through GUnicorn. We can restart Nginx, which may or may not be necessary for GUnicorn. It could, but I don't think it actually would be, but we will restart it. We'll restart our Celery beat. So all of the things on the main node are being restarted. Then we will also restart all of our Celery workers, so all of the workers know about each other as well. I don't think that's necessary either. Those should be able to just not be restarted as well. But again, restarting them is not a big deal at all. Yes, we might lose some data if we actually had sensors in terms of the time it takes to actually restart everything, but it's going to be minimal. Once again, it asks for the vault password, even though it doesn't actually use the vault anywhere. That's from that configuration, as we saw before. So that configuration right there. And so now it's going to restart all of those services. So what we should hopefully see once it does restart, there's Unicorn restarted, there's Nginx restarting, Celery Pis restarting. All of that should now flush everything out and make sure that our fourth node is actually working correctly. And so now if I refresh in here, it might be down. It might take a moment for this to be fully back up in terms of Nginx as well as Celery. But there we go. There is our fourth node in here. And now it's going to happen every 5 seconds or whatever we set it at. Again, these are random variables here, but we now see that we've added a node to the system. So what you would be doing going forward is adding all of those nodes one by one. So you could absolutely do that one by one, but just keep in mind, these are the 3 commands that you're going to want to run on a regular basis. So I'm going to go ahead and reference them on the README file. Cool. So now that we've got that, I want to mention another thing in here as far as our actual project is concerned. What we've got is we've got our CFE home inside of our Celery settings here. I did add in white noise in here. This actually didn't take into any effect whatsoever. What I did add was static files here in .getKeep. This is an empty folder because my Django static root is in here as this right here. So keep in mind that static files folder, even if it wasn't empty, if it did actually have files in here, no problems there, because when we actually deploy Nginx, what Nginx does is serve those static files, not white noise, but Nginx itself. I may have mentioned white noise can do it, and it can, but not with Nginx. I mean, it probably could do it with Nginx too, but the idea here is Nginx is actually handling that static location, which of course is the same URL as our setting is concerned. Here's those 2 settings. And so Nginx actually does that configuration for us and goes directly into that static files folder, which is why in our clone repo, in the very last tasks, we actually have this collect static. This will bring everything into that static folder, that static root directory, as you may already be aware of. So yeah, pretty cool. So at this point, we now have all of these nodes working in sync. Now your nodes probably aren't working in sync like this for a huge reason. The main reason being that we don't have a production grade database across the board. In fact, you probably have a SQLite database or something like that. The reason I actually do the production database now is because if you want to go the Ansible route, you totally can. If you want to go the Raspberry route, you totally can. You can do all of that at this point. Hopefully all of those Ansible files get you all set up for it. The reason this little detour for it was to show you practical hands-on use to make all of that happen. Now, the other thing is, how do we actually spin this up? Well, I actually find that Adafruit itself has a lot of great tutorials on using something like this sensor, this temperature sensor, where you can actually configure it on all of your different Raspberry Pis. And then instead of getting random data, you could get actual data. Doing that is outside the scope of this series. What I really wanted to show you was how to distribute Django on all of these different nodes, whether it's physical hardware, actual bare metal hardware, or you could also do it on virtual machines, which is not a whole lot different than what we did with the bare metal. Or you could actually do it using Docker Compose, which is what we're going to go ahead and switch back to, and then actually use a production database using that as well, using Timescale's production databases, because this is going to handle a lot more stuff for us, and it's going to be much more ready for something like Ansible in this distributed system. So let's go ahead and take a look at how to do that right now. Now we're going to implement a production-grade version of TimescaleDB by using Timescale's cloud service. This, of course, is a much more reliable way than what we have. All of our Raspberry Pis, even if we had a self-managed version on Raspberry Pi or Docker Compose, the likelihood of something breaking is very high. And when it comes to a database, we don't want it to break. We want it to just run. And so in this case, we're going to be using Timescale's cloud offering. So go ahead and go to timescale.com and then just try it for free. Once you do that, you're going to log into the console. It's going to look something like this. We are doing time series analysis, so that's what we want. We want to go ahead and create a service with that. So if your setup process looks a little bit different than this, that's okay. Just keep in mind that you want time series and analytics and really working off of the free tier, unless of course you need this for more production applications. So that's what I'm going to go ahead and do. I'm going to use that free tier, and I'm going to start to design or configure this service. Now, first and foremost, the actual service itself, the region, you want it to be as close to you as possible, or wherever your devices are going to end up being. Now, in my case, I'm going to be implementing this in 2 places: into the Docker Compose system that we started with, and also into the Ansible managed Raspberry Pi cluster. Now, if you want to skip the Ansible managed Raspberry Pi cluster, that's okay. Either way, what we're going to be doing here can be used in multiple places, and that's a big part of this. In my case, I'm really close to Denver, so I'm going to go ahead and use US East 1 or maybe US East 2. Ohio is probably a little bit closer. The latency here is going to be pretty negligible in my opinion. Next up, just use the free compute. 2 gigs of memory is probably plenty. I'm sure you could get a lot more compute if you need to, in terms of if you have a lot of different actual instances that you need to run. So let's say, for instance, you have 50 Raspberry Pis and you need to ingest a lot of data. You're going to definitely need to update this compute quite a bit. So definitely consider that in the long run. Now, in my case, I'm going to stick to a dev environment here, although we are doing production-like. In this case, we don't need high availability and we don't need connection pooling at this time. Next up, we're going to give it a server name or service name. I'm going to just call this Django-IoT, and we're going to go ahead and create this service. Okay. And so what's going to happen is it's going to take a few moments to actually create this up, and it's going to give us this database connection string. So you want to make sure that you download this, because if you don't download this, then you, well, might lose it for good, especially the password. You might need to reset it as you see. So you can get the connection information, you can download this configuration, or you can just grab the connection string, which is what I'm going to do. So back into my local project, into env.web container, I'm going to go ahead and do database URL equaling to this new one. This same thing I'm going to go ahead and put into env.prod. So this is for Ansible itself. I do want to show you both things if you did follow along with the Ansible stuff. So I'll go ahead and do that with simply doing something with Ansible, which of course is going back in to the root here and using Ansible-vault and then decrypt the .env.prod, hit enter, go ahead and decrypt it. Oops, and there we go. And then what you want to do is, in my case, I have an old database URL that I had in there. Now I'm going to go ahead and use this new one with the username, password already in there. There we go. Okay, so it's in both places. Now that it's inside of my Ansible, I'm going to go ahead and then just re-encrypt this production version right like that. And I'll go ahead and pass in a new password for it. Great. Now it's re-encrypted. Now that's all ready. Okay, so the first thing that I want to do is I actually want to use this locally as well. So I'm going to go ahead and just go into my standard Django project. So inside of web container, I have that. I'm also going to go ahead and grab this for the web version, or env.web. Now, granted, I've got a bunch of different versions of environment variables going on, and if you just jumped into this part right here, it might be a little bit confusing. But the idea is env.web is going to be for my local development environment. Env web container is for my local development container environment with Docker Compose. And then I've got a few other things in here. I can definitely use .db. The prod one, of course, is for Ansible. And then .env is not really used anymore. Okay, so with this in mind, I'm going to go into my local project here and just run the Python manage.py migrate command. That's it. Now, the reason for this is because this is now connecting my local Django project with the TimescaleDB cloud. And we'll actually see this if we go ahead and skip this step. And I'll go ahead and download the config as a backup in case I need to. I'll skip this step and go to the service overview. And so what we should be able to see is in the Explorer, we can already see that there's a bunch of tables in here, right? It's already showing me a bunch of tables that I'll be able to use inside of my project. This means that it's definitely ready to go. I also can see that I have a hyper table in here that I'll be able to use for my TimescaleDB connections. Great. So this is working on that. The same idea can work with my Docker Compose. But before I do Docker Compose, I'll go ahead and create a super user. It's going to be a whatever user with a whatever password in here. There we go. And so now, without using my local Django project anymore, I'm going to go ahead and do Docker Compose and watch. This, of course, should build all of the things that I've wanted to. It should build my Django project. It should have that running, and it should have multiple nodes in that Django project as well. So again, going back into compose.yaml, we should see all of those nodes. We've got node 1, node 2, node 3, and so on. Now, of course, this setup is slightly different than what we did with Ansible, and that's totally okay. Now, with all that in mind, I can also do the Ansible one as well. So feel free to skip this if you did. I'm just going to go rav run Ansible itself, and this should do all of those same configurations based off of that same vault itself. I will have to restart things on Ansible, But as far as Docker is composed, it's now running and it's running just fine. Okay, great. So with this in mind, I'm going to go ahead and now open up my Docker Compose one, which should be, let's go ahead and take a look at where it is running. So Docker Compose PS, we should see that Docker Compose web is at 8088. Okay, great. So let's go ahead and do localhost and 8088. There it is. Sure enough, that's working. Let's jump into the admin and we'll log in as our user here. And we will see that our metrics might be working, might be coming through already. It looks like they are. So these are coming from the 1, 2, 3 nodes from our Docker Compose setup. So in this case, I actually have this actual database is going to be deployed in multiple places. In the case of Ansible, I already have a few nodes on there. I have 4 nodes in my case. Yours might be different. So I'm actually going to change my Docker Compose slightly to have different nodes. So I'll do node 5. This will be the queue of node 5. Node 6, and then 6, and 7, and 7. Okay, so different queues in here for the different nodes. Once again, I made some changes. So I'm going to go into CFE Home, into Celery. Now I've got a few more nodes in here. So I'm really just treating this as a big old cluster with a bunch of different nodes. Although the data is all generated, fake, but now I've got a bunch of nodes for this Django project that I can run. So inside of Docker Compose, this will rebuild everything, but I'm actually going to need to restart Docker Compose altogether. So we'll go ahead and run that itself. Looks like Ansible maybe has failed in here for some reason. So I'm going to go ahead and run that again. Once again, this is just for those of you who did follow along with that and do want it. The rest of us are going to be using this Docker Compose going forward. But back into Docker Compose, if I were to refresh in here, eventually I'll start seeing nodes in here for those different node IDs, or at least that's in theory what should happen for the Docker Compose of it all. So let's go ahead and see if it does end up working for us. Let's go ahead and refresh. And there we go. So we got node 5 in there, and then eventually we will see a few of the other nodes coming through. I'm not sure if all of them are running just yet, so that's certainly possible that they're not. And they weren't. So 5, 6, 7, there we go. So now we've got some of those nodes, and at some point maybe Ansible will start working. And again, it will be the exact same database. It will be deployed in multiple different places, which is another reason to use a cloud database, is because then you can actually deploy it in all of these different places. And all you would need to do in this current setup is change the node IDs that you'll be running with for any given node, for the actual node itself, right? And so we've got our few nodes in here. I didn't actually change the node IDs here, but if I were to want to add another one, let's go ahead and add node 8 in here. So let's go ahead and do that. I will just call this node 8 up there. All of these other ones probably should be node 8 as well, but going ahead and adding in another one, there we go. Now going into Celery, we're going to go ahead and add another one as well, and there we go. So now we are just in a place where it's in a really good spot as far as building out a production distributed node system that will actually start working out with all of these different clusters. Now, for some reason, Ansible is not wanting to work right now. I'm not going to go through the diagnosing the different errors that might be going on with that. I will leave that for maybe some other time. And for those of you who are really interested in seeing the Ansible of it all. But the point here is to have a bunch of different nodes running within a production grade timescale version and actually bringing in a bunch of data from that timescale version. And so if we refresh in here, it's constantly going to be updating the amount of data that's coming through because it happens every 5 seconds or whatever interval that I set inside of Celery.py, which in my case I did 5 seconds just so I didn't have so much data that it just didn't make sense anymore. So that's actually really, really cool. And that's how simple it was as well. We really just went into the timescale, we sped up a database, we put it into Django, and then we just let it rip. It's actually really straightforward, really easy to do with all of this configuration. So the next step, of course, is going to be then visualizing these things. So we actually want to take this data, do some querying, and actually start visualizing it. Now, the querying of this data is going to be sort of nonsensical. It is going to have the time series thing, so we'll learn a little bit more about how to do the querying inside of Timescale with Django, and specifically the Django-Timescaledb package. But the idea here is we're using not really good data because it's all random. It's random between a pretty big range, but we can still see what's happening with that data by using the things that Timescale does really well. Now we're going to take a look at how to query and aggregate data from our TimescaleDB instance. This will work on a self-hosted one. It will also work on the cloud one that we have right now. So we actually want to turn these queries into eventually visualizations. So the way we're going to do this is we're going to create a query with an API, with a REST API. The API itself is going to be using Django Ninja to make all of this happen. It's actually really easy to do, as we'll see. But the idea here is we need to make a query set from TimescaleDB, so the actual package itself. We make a query set from there, leveraging the built-in feature that has .timescale, basically. And so we will actually go ahead and do a query here, and then we will actually then turn it into JSON-ready data so that a front end or chart.js will actually work correctly. So to make this work, we're going to go into our project here. We're going to go into requirements.txt, add in Django-Ninja. We'll go ahead and run our pip installations here. Let's go into the root of our project with pip install-r requirements.txt. There we go. Next up, we're going to go into CFE home and create a new file called api.py. This is where we're going to go ahead and create our API service using, of course, the Django Ninja project. So the way it works here is we're going to just do a baseline Django Ninja project to start, and then we'll implement the query itself. So we'll import from Ninja. We're going to import the Ninja API. We're going to go ahead and create the API just like this. So this initializes the API itself. And then we're going to go ahead and do @.api get. And this is going to be, I'll just go ahead and say like something like temps, something like that. Then I'll go ahead and do define get average temps. And this one will take in the request, and then we'll go ahead and return back the values that we want. So in this case, I'll just go ahead and say hello world to start, because that's all we really need for our API itself. So with this in mind, I'm going to go into my URLs here, and I'm going to create a new path for this. And this is going to be path, and it's just simply API / whatever we want to name this itself. Then what we want to do is we want to bring in the API from here. So what we see in the docs, you see that you import from the module API, import the actual variable here of API. So we'll go ahead and do that now. So we'll do from .api import API, and then we'll go ahead and wrap this in here with api.urls. That's it. That's really all we need to do in terms of our Django Ninja project. Now I have Docker running, which is rebuilding everything. I'm also going to go ahead and run my Django project locally. So I'll go ahead and do python manage.py, run server just like that. And let's make sure that we're spelling it correctly. There we go. And so the reason I'm doing this is because my actual database, my production, TimescaleDB database is the same in many different places. It's the same on the web. It's the same in production. It's the same on this container right here. So all of them are using the same database, which really just helps me do some rapid iteration here. Now, when I actually go into production, my development mode database should not be the same as my production one. Of course, hopefully you already know that. Now, the idea here then is we're going to jump into our local host. I think it's at 8,000. So we'll go do localhost 8,000 here. And then I'll go into /API and then /temps. There we go. There's our hello world. Great. So now that we've got this, let's go ahead and take it one step further and start building out some various aggregations in here. So the way we're going to do this is by coming into our sensors, and I'm going to create a new file in here, and I'm just going to call this services.py. The reason for this is just to really allow models.py to live as itself. Services will use models.py. So the first thing that I want to do is from django.db.models, we are going to go ahead and import a AVG or average. So this is something we can call as a aggregation across a query set. So what I want to do here in this services, I'm going to go ahead and do get average temp, something like that. And that's going to return back, well, our metric. So we'll do from.models. We're going to go ahead and import metric. And what we could do here is we could just bring in the query set for it. So the query set is going to be, we'll put it into parentheses. We'll do metric.timescale. Then we're going to go ahead and filter this down to a specific range. Now, this is coming directly from their documentation, so it's not a whole lot different than what we've got right here in the actual time range and all this stuff. So that's what we're going to be doing. So the range itself, I'll go ahead and give a range. the range that I want is going to be, we'll call this our time range. The range I want is going to be from django.utils. We're going to go ahead and import time zone. And then I'll also go ahead and import a few things from date time. We're going to import time delta and maybe date time as well. Okay, so we've got our time range here. This is going to be fairly straightforward. It's going to be now. So we'll go ahead and say now equals to time zone now. So we'll just go ahead and say now minus the time delta of, let's go ahead and do days being 1. Realistically, it'd probably be more like hours because of how our metrics are working. But this is just going to give us our recent days, and that's it. So the range itself is we now have our filter here that we can use for our ranges. So what often happens is when you see ranges, you'll see that the first range, so the actual starting range, we'll go ahead and say start range. And this is going to be our now, which is fine. So we're going to go ahead and bring in the time underscore range equals to the start range to now. That's it. So this is going to filter those things down, which of course is nice, but it's not really doing a whole lot for me. So the reason I put these parentheses in here is I can actually hit enter after that period so we can really stack this query together quite a bit more. So the next thing that I want to do here is I'm going to go ahead and just annotate, and we're going to annotate the average temp equaling to average of the field that I want, which is, of course, temperature. Okay, so we can see how this ends up playing out. Now, the way I'm going to do this is first off jumping into the Python managed shell. So let's go ahead and jump into the shell, and we'll do python manage.py shell, and then from sensors, we're going to go ahead and import the services in here. And let's make sure that it's correct. And there we go. So then I'm going to go ahead and do services.getAverageTemp. And we'll run that. And what we should get back is stuff related to this. But unfortunately, what we've got is this has to appear in a group by clause in the way it ends up working here. So we need to actually do one more step, which is actually truncating this data and then grouping it together. So what that means is we filter by this range. Then what we're going to do is just do another level here, and we'll say annotate again. This one is going to be our time group, and we want to truncate minutes of the time field itself. Now, this is going to allow me to get averages over minutes itself. You could change the actual time that you want to truncate, but in our case, we're going to go ahead and leave it in as just simply minutes. So this is another database function that we can bring in here, just like that. So this will give us a time group that we can now chunk things into, and then we can go ahead and do values being time group. This groups everything together, in which case we then get our annotation. So let's go ahead and try that again. I'm going to exit out of here and then re-import it and then rerun it. And so now we get our average temperatures for minutes. Wow. Now, this is a little bit hard to see exactly what's going on. So naturally, we want to visualize this. Now, one of the other things that I'll probably want to do here is order this by that time group, just to make sure that the actual times are in order. They should be in order, but this is just making sure that that's the case. Okay, so now that we've got this data, what I want to do is I want to bring this into that API. So back into the API here, we're going to go ahead and do from sensors, and we're going to go ahead and grab in from models. We're going to import the metric. Actually, we'll leave out the metrics for now. We'll just go ahead and do from sensors, and we're going to import services. So my query set is going to be services.getAverageTemp. So what I want to do is I actually want to return back this query set. So as it stands right now, what we can't do is just return a query set like that is according to Django Ninja. We could try to do it. Let's go ahead and see what happens. If we do, we get this is not JSON serializable. So that's not actually that surprising because this is not JSON data. Typically speaking, with a REST API, it needs to be JSON data. So how do we actually turn it into JSON data? With Ninja, it's super easy. First off, we change the schema here. So the schema itself is going to be a little bit different. So we'll go ahead and do class, and this is going to be our average temp schema. And this takes in schema here. Now what we want are the fields that are coming back. The fields are average temp, which is a float, and then time group, which is a date time object. So we'll go ahead and do that. Average temp, this is the data type of float, and then our time group is going to be our date time object. So I need to import that one here. So we'll go ahead and do that from date time, import date time. There we go. So this is now the schema that we want to respond with. Now, when it comes to these schemas, this of course goes back to Django Ninja. How do we actually do this response? So if we go into altering the response here, what we can do is we can define a schema rather. We've got our data in. This is data coming in. So there's a way to validate the data coming in, but there's also a way to respond with a specific schema going out, as you can see in the documentation itself. So that means then I can give my response being of this schema. So what Django Ninja does really well is it will take a query set of some kind and turn it into this schema. This is a Pydantic model if you want to look more into Pydantic itself to have more robust schemas. But with this in mind, I can now go back into my API. I should be able to refresh in here, assuming that I've got everything running. And this should be response, not response. There we go. Now we're back in here with our actual schema data itself, and we get this error. It's saying average temp is required and time group is also required. So why is this happening? Well, it actually has to do with the fact that we are returning a query set, an actual list of items. So if I actually just did first in here, save that, and then refresh on here, we should see that data. I actually want the entire list to come back, but here we go. We are now serializing this data. So in order for this to be an actual list, what we do is we get rid of that dot first, and then we do from typing, and we import list here, and then we just declare the data type being a list of those average temp schema. We save it like that. Again, we refresh in here. Now we've got a list of all of this data that's coming through from our recent averages. Pretty neat, right? So this is accurate to this random data. Not surprising, the data is all over the place in terms of real temperatures, but what we see here is the actual data working correctly. And as we see, it's also based off of the minutes and all of that. So all of these aggregations under the hood are really efficient thanks to TimescaleDB. So I get it. Some of these things you can do with Django by default, but the thing is the actual filtering based off of this range, that works really, really well and really easily thanks to just using our TimescaleDB. But I actually want to take this one step further and use another API for our various nodes, because right now we have a bunch of different nodes. You might want to see that as another option for your temperatures themselves. Back into our sensor services, we're going to go ahead and create another one, and this is going to be now called our get node average temp, which this is actually really easy to do as well. We grab the time group, and then we actually bring in our node ID as one of the values in there. From there, it's going to go ahead and do the same sort of annotation here, and then the actual ordering itself will be time group and simply node ID. There we go. So now that we've got this, I can go back into my API itself, still have services imported here. Now I'm going to go ahead and do temps/node, and then there's going to be get node average temp. The schema itself is slightly different. This is going to be basically the same thing, but now it's going to be node average temp. And then we're going to go ahead and bring in our node ID, and there's going to be an integer itself. And so this is going to be the one we respond with. So now that we've got that, let's go ahead and make sure our server is still running. And sure enough, it is. Let's go back into here, into our API, and then do just simply /node. And there we go. We now have our node IDs and then the time that it occurs, right? So it's going to be based off of a realistic time scale that's coming through in here. And so you can see that it is increasing over time. And of course, there's a lot more data in here. So you might actually want to limit the amount of data that's coming back on this request. That is something you can look through the Django Ninja documentation for. But the general idea here is we can now actually display this data as well. Now, of course, there's other things that we can play with as well. So let's go ahead and grab something else in our services. Let's say, for instance, we want to get the max and min temps. So I'm going to go ahead and get node. Let's go ahead and just start out with get max min temperatures in here. Okay, so this is going to be another database lookup here. So we do max and min as our imports for our models. So we can do the exact same range. We can obviously change the range to be based off of environment variables or even as arguments in here. But the idea being that we actually grab our data. So we still have our range here overall. Then what we want to do is we want to actually grab in, this is going to be for all of them. So I'll go ahead and leave the time group out. Actually, I probably don't even need that time group. So what I'll just do is say dot aggregate, and we'll go ahead and do max and temperature, and then min and temperature, right? There we go. And I can set these values as like max temp equaling to that, and then min temp equaling to that. And there we go. So back into our API, we want to go ahead and grab those same things. I'm going to go ahead and grab it from the temps to start. Of course, the schema is going to need a change, but this is going to be temps max, or we'll call it max min, just so we can see what that is. This is going to be a new schema now, which should be, let's go ahead and copy this. It should be max temp and min temp, also being floats. And there's going to be our max min temp schema. And we'll go ahead and bring that in as our max min. There we go. And so in this case, it actually probably is only going to be one value. So it shouldn't be a list here based off of what we did with that aggregate call. So in that aggregate call back into the service, this aggregate will only bring back that stuff. It's not going to annotate anything. Where what's happening here is it filters down the stuff, it annotates it, and then it groups everything together. And then it's going to go ahead and annotate based off of that grouping. It's going to then annotate the temperature based off of that grouping, and then it'll order things also based off of that grouping. Where this, it actually bundles everything up into either the maximum temperature, which this is doing the calculation on the database side, or the minimum temperature, also on the database side. In other words, this is a query that the database is handling itself. Our Python functions don't need to do anything other than design the query. That's exactly what query sets are and what they're for. So what should return back is just two numbers here, which is why we have the max min schema as one single item of max temp and minimum temp. And let's just make sure that we did max and min temp just like that. So the actual schema itself is based off of those values. Now that we've got that, let's go ahead and take a look at that. And we called it max min. Hit enter, and once again, here's our maximum minimum. Now, there's no surprise here, most likely, about these temperatures. This, of course, is not really accurate in terms of real data, right? But it is accurate in terms of how we were generating our random data itself. So that's between 0 and 130. What do you know? It's between 0 and 130. Not surprising at all that those are the maximum minimum temperatures, but it is really nice to see. Granted, if our actual sensors were working, we would then have those sensors. Now, this is for everything. What if we wanted to do it for individual nodes? Now it's going to be get max min node temp, right? And so it's very similar still, but then we just add in something else here, which is going to be our values of our node ID. And now we're going to have a very different look at this. So what I want to see here is I'm going to go back into my API. I'm going to grab that services here, and I'll call this QS2, mostly to just see what's coming through here. And then we'll go ahead and do get our node max min temp, and we'll go ahead and print out QS2. Save that. Jumping back into our API, let's just go ahead and refresh in here. And so we get our min max 2 in here. So it's actually coming back as the same one. So it's not quite what we wanted. So let's go back in here. We got our values of our node IDs here. So instead of aggregate, we're now going to go ahead and do annotate, and then we're going to go ahead and do .order by, and this is going to be our node ID. So let's go ahead and give this a try. We'll refresh in here, and let's go ahead and see our print statement, and there is now that same information based off of the IDs that they actually have. So then going back into our API here, I'm going to go ahead and duplicate this one. And this one is going to be slightly different, of course. Once again, I will just use this max min here. And this is going to be our nodes / max min. And so we'll get rid of some of these calls that are coming through. Get rid of this one up, or rather this print statement up here. And then the actual schema itself, this is going to be copied. And this is now going to be our node max min schema. And then again, our node ID being an integer. And once again, it's going to be a list this time because it's going to be a bunch of different objects that are coming back. And so we'll put that list in there once again So going back in here now, I'm going to go ahead and do my node maxmin, and what would we say? Nodes maxmin, and there we go. So now we've got all of our nodes in here. Now, not surprising, once again, all of the data basically fits in roughly the same thing. It's not that big of a deal in terms of how that ends up looking, but we can now see how quickly we can go from ingesting data to a fairly powerful API itself, just by using, of course, the things that are built into TimescaleDB and, of course, the things that Django Ninja works with out of the gates. So now that we've got this, we just need to visualize some of this data. I'm not going to visualize that much of it, but mostly just to show you a proof or a work of concept for some of our temperatures that are coming through in here, just so we can get a sense of how that would all work if you wanted to start visualizing this time series data. Off the video, I went ahead and created a views.py for a homepage view. Inside of settings, I added the templates directory here, as you can see right there. And then I also added in a home.html page, mostly so that I can render out some charts using chart.js. And then, of course, I added it into the URLs as well, so that when I go to the home page, it looks a little bit more like this, just a blank page at this point. So inside of chartjs.org, into getting started, we're going to go ahead and create our first chart just by copying what is here. So I'm going to copy that and paste it into the body of my home.html. And then I'm going to go ahead and take a look at it. There we go. We now have a chart. So of course, what I want to do is I want to change this chart to be based off of my data. Now, to start out, this is actually fairly straightforward. What we're going to do is we're going to change the labels to our dates and then change our data to our average data. That's it. So that's what we need to do now. And I also want to change the type to being line. So it should be a line value. That actually makes a lot more sense to me when it comes to temperatures themselves. Now, we are going to have a lot more temperature data points than this. So we'll just keep that in mind when we actually design this out. But the idea, of course, is going to be fetching out our data. So the way this works is we're going to go into fetch API to temps. And what this is going to allow us to do is say then x equals to x.json. This is actually the response. So the response from that request. And then finally, what we can do is say x as in the data itself. We can console log that data. I will change it to being just simply data for a moment. We'll save that. We'll refresh into our home page here. We will inspect the element, go into the console, and we should see a bunch of data coming through. Okay, so if you can get to this part, the next part is not that much different than what we just did. I'm going to change this to being simply X so that it doesn't get confused in terms of data with anything else. Now, the first thing that I want to do is I want to grab in my labels. Now, what are the labels? In this case, it's going to be x.map, and then it's going to, what we're doing here is we're going through the list that's responded to us. We're going to map this out so that it only has our time group data in here. So the way this works is we can say this is something like subdata, and this is equal to subdata.time group. So basically listing all of these things out and just returning back just the time group. That's what's happening here. If we were to repeat this, we could go ahead and say that our actual data set data, something like that, same sort of mapping, but this time instead of time group, it's going to be avg_temp. Really just that simple. So what I want to do is I want to actually bring this chart, I want to bring that chart data into the fetch call. So that's when it's actually created. So I'm going to go ahead and cut this out here and paste it right underneath those map functions. So now we've got labels here that I can just go ahead and paste in right there. And I've got dataset data that I can paste in right here. And then I can change this label to that. Instead of number of votes, we can just do average temp. We can save that and we can refresh in here. And there we go. So now we have a chart that's visualizing the average temp going up and down over time. Pretty neat, right? Obviously, it's hovering around the actual middle of the data set. This, of course, makes a lot of sense because the middle of the data set is roughly what the random values would actually come up with, as in between 0 and 120. And that makes sense for the averages. Great. So that's a really simple way to visualize this data. Now, of course, Chart.js has a lot of other options that you could go into, but the point here is really just to visualize it quickly. There's a lot more graphs and charts that we could end up building, but the next one I want to see is really the average temp per each node. This is quite a bit more complex, so let's go ahead and take a look at how this is done. Off the video, I copied home.html and brought it over to nodes.html because I want to actually change the API endpoint, but keep reference to the old one. The API endpoint is simply API/temps/node. And of course, we could go ahead and take a look at this on our project and see what comes out. Now, in this case, it actually gives us a lot more data than the previous one because now we're parsing out that data into individual nodes. So if we go back into that home page with that new API going, it actually gives us a lot more data points over time. So this is actually kind of interesting, but the problem here is it's not actually separating out the lines based off of their node. So that's actually what we want to do now. That means that we need to reparse out the data. In other words, we need to have multiple data sets in here that are per node with basically the same idea in terms of labels. So making this work is a little bit of a tedious process, so I'm actually going to go ahead and just give it to you. So the first thing is we're going to go ahead and change this to data. With that in mind, we're going to go ahead and bring in our nodes. The nodes itself is going to map that data, and it's going to look for each node ID. You also might consider sorting this data with A, B, and then doing something like A minus B. That will help sort out all of the nodes that are coming in there. And so if we actually changed our labels to nodes and then changed our data set to being empty, we would be able to see what these nodes are. So we save that and we can refresh in here. Now we've got node 1, 2, 3, 4, 5, 6, 7, 8, and that actually makes sense for all of the data points that we've been using. So once again, it's actually going to go ahead and use a set because it's going to take all of those nodes and then just turn it into the few that are left, and then we sort them out. Next up, this one's a little bit tricky, but it is the time labels themselves. So this is the actual labels that we'll end up using, not the ones that we were using. This is the one because what it's going to do is it's going to map through all the data, look for the time group itself, and then sort it based off of that time group. So these are the actual labels that we'll be using inside of our different data sets. So down here, instead of it being nodes, it's going to be these time labels. When we take a look at that now, these are the time labels that we've got. So this is some hours over time, over recently. Now, there's a lot of things we could do to modify this. We could also consider this as its own API endpoint just to get the labels themselves, then get the data in a separate manner. In other words, our API could do a lot of the heavy lifting that we're doing right here inside of JavaScript, which is why I'm just giving you the JavaScript itself. So the next part is actually the data set that's going to be used. So I'm going to go ahead and copy and paste this once again. And so what we've got here is we've got all of the data based off of the node IDs. So in other words, we're going to iterate each node itself. Then we're going to filter for that node data based off of the fact that either that node data exists or doesn't. And so this is going to filter down our main data set based off of its ID. So let's say, for instance, node 1, it's going to filter all of those down. Then we're going to go through and grab all of that data. Then we're going to grab all of the data timestamps based off of the time labels that are coming from before. Once again, this is a little bit complicated if you haven't done something like this before. But the idea is we've got our time labels in here. These are going to be all of the same time labels for all of the data sets. If the data set, if any given node doesn't have that time label, then we're going to set it being null. It's just going to be empty. If it does, then it's going to go ahead and look for that average temp. So that's what's happening here. It's filtering based off of the time group and then, comparing it against the time label itself in the ordering that the time label is on. Then we actually create a whole data set from that. And then with that data set, we can then go ahead and bring it in like that. And then this becomes our new table, right? Our new table altogether. And so I can refresh in here, and it's quite a bit more data. It's definitely more chaotic because I've got a lot more data, and we could spend a lot of time in terms of improving the way this ends up looking and working. One of the things we could do is just go ahead and change our options in here as well. So let's go ahead and do that. I'm going to bring in the options here. Hopefully I didn't break anything. Let's go ahead and refresh, and there we go. So the scales are a little bit different. It doesn't go down to 0. It's now showing a little bit better of averages over time for any given node. And of course, only for the last few hours. That I think is pretty neat. Now, again, this is very complex in terms of how it's looking, but there would be a trend line overall if we wanted to see it. What I would actually do is have individual nodes charted out themselves. So each chart would have its own node so that we can get a better visual as to what's going on instead of mapping all of them on top of this, because with 8 nodes, it is something else. If we had only a few nodes, then that might be also something else. So let's go ahead and see how we could probably do a few nodes. I'm going to go ahead and get rid of this set that's here just by commenting this part out. And then I'll do const nodes equals to 1, 2, 3, and 4. Save that. Refresh in here. Now our data is, well, a little bit easier to read, or at least a little bit easier to see. And I could also take this down even more. And so I can save that and refresh in here. Now, once again, we can see this data a little bit better against each other. Now, this is where you would want to learn a lot more front-end stuff, like using something like React.js or even just pure JavaScript, vanilla JavaScript like we've been using, to really leverage all of the data that's coming through. That, of course, is a little bit different than getting all of this up, but I did want to show you just a very basic way on how we can generally see this data. And so this is actually something that I think is very powerful about using TimescaleDB. This, by default, is done over time. So all of this is time series data. So what we could do from here is we could start doing other sorts of analysis like regression, seeing if there's a pattern that's happening with all of this data. And of course, something like that is really interesting, but it's outside the scope of this series because we are now done. So please let me know if you want to see some regression or other sorts of visualizations, or really just anything else with TimescaleDB in the comments below. Hey, thanks so much for watching. Hopefully you got a lot out of this one. And thanks to TimescaleDB for helping bring this course to life. Now, of course, using Timescale gave us the advantages of Postgres along with time series data, doing all sorts of analysis on time series data. This really just scratched the surface of what you can do with time series. It's really great for all sorts of machine learning models as well. So the challenge I leave you with is really just, spin up some sensors and put them on some Raspberry Pis all throughout your house or your warehouse or your office, and actually start to measure real-time sensor data, whether it's temperature or any other kind of data. The point being that you now have the grounds to be able to do so. Now, I realize there's a lot of pieces in this that you might be super interested in learning more of. Please let me know about those things in the description. It could be something like visualization. It could be how do we actually monitor our different nodes in a more robust, scalable way. Maybe we want to actually deploy containers to those nodes instead of the way we did it with Ansible. There's a lot that you can really do with IoT and leveraging something like Django and Celery in this whole ecosystem. And of course, a TimescaleDB to get that time series data as you might see fit. Now, a big part of this, what I'm really interested in, is where this goes in terms of robotics. I really think that these Raspberry Pis and the way we set this up is really going towards what you might end up doing in the realm of robotics. This setup, this system, is in many ways a way to scale up and monitor a bunch of different devices at once from really a central project, a Django project. Now, the key thing about all of that, though, is at some point, we want the nodes to be able to join themselves. That's yet another challenge that you would want to undertake. In other words, we spin up a node and then it automatically starts connecting to the system and scaling itself up. That is not a trivial task, but it is a really good challenge. So thanks again for watching. My name's Justin Mitchell. Look forward to seeing you next time.